To imagine a world where giant creatures roamed, their footsteps echoing across ancient landscapes, a time when dinosaurs dominated the Earth for over 165 million years. This extraordinary era, rich with bizarre species and unprecedented environmental changes, continues to captivate our imaginations and scientific inquiry. As we journey through the age of dinosaurs, we will explore the remarkable diversity of these prehistoric giants and delve into their daily lives, uncovering their intricate relationships with the ecosystems around them. The Mesozoic era, often referred to as the Age of Reptiles, is a remarkable chapter in Earth's history that lasted for about 180 million years, beginning around 253 million years ago and concluding about 66 million years ago. It is defined by a series of significant geological, climatic, and biological changes that shaped the world in ways we can still recognize today. During this time, the supercontinent Pangaea began to break apart, leading to the formation of separate land masses. This shifting landscape had profound effects on the climate and the habitats available to living organisms. As the Mesozoic unfolded, the planet experienced a warm climate with higher sea levels, resulting in lush environments that were perfect for plant evolution. The era is divided into three periods: the Triassic, Jurassic, and Cretaceous. Each of these periods saw the emergence and diversification of various species, but it was during the Triassic period that dinosaurs began to rise. These early dinosaurs were small and agile, thriving in the warm, dry conditions, while other reptilian groups began to flourish alongside them. The Jurassic period witnessed a dramatic expansion of dinosaur diversity. This was a time when dinosaurs truly became the dominant terrestrial vertebrates, evolving into a wide range of forms, from the massive long-necked sauropods to the swift predatory theropods. The warm climate and abundant vegetation allowed herbivorous dinosaurs to flourish, thus supporting the larger carnivorous species as they evolved. The interactions between these various groups created complex ecosystems where competition, adaptation, and survival played crucial roles. By the time we reached the Cretaceous period, dinosaurs were truly ruling the land. Their vast sizes and variety meant they occupied numerous ecological niches. This period also saw the appearance of flowering plants, which provided new food sources and further influenced the evolution of dinosaurs. The stage was beautifully set for these magnificent creatures, who would dominate the planet for millions of years, leaving behind a legacy that fascinates us to this day. During the Mesozoic era, which spanned over 185 million years, the movement of Earth's continents significantly shaped the evolution of dinosaurs and their habitats. At the beginning of this era, Earth's land masses were clustered together in a supercontinent known as Pangaea. This vast expanse of land provided a diverse range of ecosystems, influencing the variety of life that would eventually inhabit these areas. As the Mesozoic progressed, Pangaea began to split apart, giving rise to the continents we know today. This continental drift created new oceans and isolated dinosaur populations, allowing them to adapt to different environments. For instance, as continents separated, dinosaurs on one landmass might evolve specific traits that suited their unique ecological niches, while those on another landmass would develop entirely different adaptations in response to their surroundings. This isolation was a key factor in the diversification of dinosaur species. Moreover, the shifting continents altered climate patterns and sea levels, impacting the habitat where dinosaurs thrived. For example, as land became more fragmented and new coastlines were formed, dinosaurs began to inhabit lush forests, open plains, and arid regions. Different dietary needs led to the evolution of herbivores with specialized teeth for grazing on the varied flora, while predatory dinosaurs adapted to chase down these prey amid changing landscapes. The continental drift during the Mesozoic era played a crucial role not only in shaping the physical world in which dinosaurs lived, but also in driving their evolution. As continents drifted apart, they opened the door for a multitude of dinosaur species to adapt, diversify, and flourish in a dynamic and ever-changing environment. This fascinating interplay between geology and biology contributed to the rich tapestry of life that characterized the age of dinosaurs. During the age of dinosaurs, also known as the Mesozoic era, the Earth experienced a range of climatic conditions that fostered diverse ecosystems. This era, stretching from about 253 million to 66 million years ago, featured a generally warm and humid climate. It was significantly different from today's climate, lacking polar ice caps and maintaining a generally higher average temperature. This warmth contributed to lush vegetation, which flourished in many regions. The Mesozoic world also witnessed dramatic shifts in sea levels, creating shallow inland seas that divided continents. These seas, teeming with marine life, fostered nutrient-rich environments for various ecosystems. Coastal areas and river deltas became hotspots for biodiversity, where plant life thrived alongside a multitude of animal species. The combination of diverse habitats, from dense forests to open plains, greatly supported the flora and fauna that evolved during this time. Plant life during the age of dinosaurs was predominantly made up of gymnosperms, such as cycads and conifers, and later, flowering plants made their appearance. This wide range of vegetation not only provided food for herbivorous dinosaurs, but also created rich environments for countless other organisms. These plants played a crucial role in stabilizing the climate by maintaining atmospheric carbon dioxide levels, contributing to the persistently warm temperatures that prevailed across the planet. In addition to these conditions, volcanic activity was more prevalent during the Mesozoic, releasing greenhouse gases into the atmosphere and further enhancing the warm climate. The resulting ecosystems were vibrant and teeming with life, allowing dinosaurs to flourish. As a whole, the unique climatic conditions of the prehistoric world were pivotal in nurturing the extraordinary diversity of life that characterized the age of dinosaurs, setting the stage for the evolutionary wonders we marvel at today. Dinosaurs were remarkable creatures that inhabited our planet for over 160 million years, and their success in diverse environments is a testament to their incredible adaptability. These prehistoric reptiles adapted in numerous ways to thrive in varying climates, geological conditions, and ecological niches. From the lush forests of the Jurassic period to the arid deserts of the Cretaceous, dinosaurs developed traits that allowed them not only to survive, but to flourish. One of the most significant adaptations seen in dinosaurs was their body size. Some species, like the majestic sauropods, grew to enormous lengths, which helped them reach high vegetation for food and deterred many predators. In contrast, smaller dinosaurs, like the cleverly adapted theropods, were agile and quick, allowing them to hunt efficiently or evade larger threats. This variation in size and agility showcases the incredible range of adaptations that allowed dinosaurs to occupy different ecological roles, from apex predators to herbivores. Another key adaptation was their diverse feeding strategies. Some dinosaurs were equipped with complex teeth like those of the hadrosaurs, adapted to grinding plant material, while others, such as the sharp-toothed velociraptors, were built for capturing and tearing flesh. Certain species developed the ability to switch diets, allowing them to take advantage of whatever food sources were available. This flexibility in feeding habits illustrates how dinosaurs could thrive across various habitats, from dense forests to open plains. Finally, dinosaurs exhibited fascinating adaptations regarding reproduction and social behavior. Some species created nests and cared for their young, ensuring higher survival rates in their vulnerable early lives. Social behaviors, such as herding in certain species, offered protection against predators and improved efficiency in finding food. All these traits worked together, forming an intricate web of adaptations that enabled dinosaurs to survive and dominate for millions of years, leaving behind a legacy that continues to capture our imagination today. Vegetation was a crucial part of the ecosystems that existed alongside dinosaurs, forming the backbone of their food chains and habitats. During the time of the dinosaurs, the Earth was rich with diverse plant life, including ferns, cycads, and seed plants. This variety of vegetation provided nourishment for herbivorous dinosaurs, which in turn became food for carnivorous species, creating a complex web of interdependence. As dinosaurs roamed the land, they also influenced the evolution of plant life. Large plant-eating dinosaurs like the sauropods grazed on extensive amounts of foliage, leading to adaptations in plants. Many trees and shrubs developed tougher leaves or grew taller to avoid being eaten, while others evolved defenses such as thorns or toxic chemicals. This ongoing relationship between plants and dinosaurs illustrates the dynamic nature of ecosystems, where the presence of one life form can spurn change in another. The Mesozoic era, spanning over 180 million years, was characterized by significant shifts in vegetation. Early in this era, during the Triassic period, the landscape was dominated by cycads and ferns. Over time, especially in the Jurassic period, flowering plants began to emerge and diversify, providing new food sources for dinosaurs. This was a revolutionary change, as ants and bees also evolved during this period, resulting in complex interactions that helped shape the world we know today. As the Mesozoic era came to a close, around 66 million years ago, the catastrophic events that led to the mass extinction of dinosaurs also drastically altered plant ecosystems. Many species of plants were wiped out, while others that survived adapted to the new environmental conditions. This paved the way for the rise of mammals and birds, demonstrating that the interplay between vegetation and fauna continues to shape life on Earth, just as it did in the age of dinosaurs. Dinosaurs, those magnificent creatures that roamed the Earth millions of years ago, can be broadly classified into two major groups. The first group is known as the Saurischia, which includes the meat-eating theropods and the long-necked sauropodomorphs. Theropods are particularly fascinating, as they include well-known species like Tyrannosaurus rex and Velociraptor. On the other hand, the sauropodomorphs are characterized by their massive size and long necks, with giants like Brachiosaurus and Diplodocus towering over the landscape. The second major category is the Ornithischia. This group primarily consists of herbivorous dinosaurs, which were adept at grazing on plants. Ornithischians showcase a remarkable variety of body shapes and sizes, from the armored Stegosaurus to the duck-billed hadrosaurs. A unique feature that distinguishes ornithischians is their beak-like jaws, which help them efficiently strip leaves and other vegetation. While the Saurischians and Ornithischians are distinct groups, they both highlight the incredible diversity that existed among dinosaurs. Their differences are not just in diet and size, but also in physical adaptations. For instance, theropods, being predators, evolved sharp claws and teeth suited for hunting, while many ornithischians developed defensive traits, like armor plating or the ability to herd for protection. Remarkably, some of the theropods eventually adapted to flight, leading to the birds we know today. This evolutionary connection sheds light on the intricate web of life that existed during the age of dinosaurs, showcasing their adaptability and the dynamic nature of evolution itself. Understanding these classifications not only enlightens us about the past, but also gives us a glimpse into the wonders of the living world that evolved alongside them. Theropods, the group of dinosaurs that includes the mighty Tyrannosaurus rex and the swift Velociraptor, present a fascinating array of characteristics that provide insights into dinosaur evolution. One of the most striking features of theropods is their bipedal stance. Standing upright on two legs allowed them to develop remarkable agility and speed, making them effective predators. Their limbs were adapted not just for movement, but also for grasping and hunting, with some species possessing sharp claws and, in the case of certain lineage, feathers. Another notable characteristic of theropods is their respiratory system, which in some cases resembled that of modern birds. This adaptation included air sacs that facilitated more efficient breathing, a trait that is believed to have contributed to their high metabolic rates and active lifestyles. The discovery of feathered theropods in fossil records has sparked intriguing conversations among scientists regarding the evolutionary link between dinosaurs and birds, suggesting that the roots of avian flight are deeply embedded in theropod ancestry. Additionally, theropods exhibited a diverse range of sizes and dietary habits. While some were towering carnivores, others evolved into smaller, nimble forms, allowing them to exploit various ecological niches. This diversity highlights the adaptability of theropods and sheds light on how evolutionary pressures resulted in the wide array of dinosaur forms. Their fossilized remains also show evidence of social behavior, such as pack hunting, which indicates complex interactions within species. The traits observed in theropods reveal a dynamic evolutionary path marked by innovation and adaptation. By studying these extraordinary creatures, we gain not only a better understanding of their biomechanics and ecology, but also insight into how such remarkable developments paved the way for the emergence of birds, illustrating a continuous thread of evolution that connects the past with the present. The tale of theropods enriches our understanding of life on Earth and highlights the remarkable transformations that can occur over millions of years. The tale of theropods enriches our understanding of life on Earth and highlights the remarkable transformations that can occur over millions of years. Herbivorous dinosaurs, a diverse group of plant eaters that flourished during the Mesozoic era, showcased remarkable adaptations that enabled them to thrive in various environments. One of the most notable adaptations was their body structure. Many of these giants developed elongated necks and massive bodies, which allowed them to reach and consume foliage high in trees, accessing a source of food that smaller or shorter dinosaurs could not. For example, the long-necked sauropods, such as Brachiosaurus, were able to graze on treetops, exploiting an ecological niche that greatly reduced competition for food. Additionally, their teeth were uniquely adapted for their diet. Unlike carnivorous dinosaurs with sharp, serrated teeth designed for tearing flesh, herbivorous dinosaurs had flat or grinding teeth that could effectively break down tough plant material. This design was crucial for processing fibrous plants, which required efficient chewing to facilitate digestion. Some species even had complex dental structures that worked together to grind and crush, similar to how modern elephants or cows use their molars. Feeding habits also played a significant role in their survival. Many herbivorous dinosaurs were selective feeders, adapting to consume specific types of vegetation, thus allowing them to thrive amidst the varying plant life of their habitats. For instance, some species would prefer softer, more nutrient-rich leaves, while others might consume tougher, lower-nutrient grass. This variety in feeding strategies helped them maintain health and energy levels, especially during periods of environmental change. Moreover, competition and predation pressures influenced their behavior. Many herbivorous dinosaurs, such as the armored Ankylosaurus or the spiked Stegosaurus, developed physical defenses, like hard scales or spines, against predators. Their size itself often served as a form of protection, with larger species being less susceptible to attack. By evolving both feeding adaptations and defensive traits, these dinosaurs not only survived, but dominated the landscape for millions of years, leaving us fascinated with their legacy. Sauropods, the long-necked giants of the dinosaur world, exhibited remarkable size and physical structure that significantly influenced both their behavior and habitat choices. These colossal creatures could grow to lengths exceeding 100 feet and weigh as much as 50 tons. Their sheer size offered them a distinct advantage in their environment, primarily by allowing them to reach high vegetation that other dinosaurs could not access. This characteristic led to a feeding strategy that focused on browsing the tops of trees, enabling them to thrive in forests dominated by tall flora. The physical structure of sauropods played a critical role in their locomotion and social behavior as well. Their long necks were not only useful for feeding, but they also allowed these gentle giants to communicate with each other over long distances. This effective long-range communication might have been crucial for coordinating movements within herds, promoting social structures vital for their survival in the often harsh prehistoric environments. Rather than moving solo, many sauropods traveled in packs, providing safety in numbers from potential predators. Their size also influenced their reproductive strategies. The larger the animal, the more significant the energy requirements for raising young. Female sauropods are believed to have laid large clutches of eggs at once, increasing the likelihood that at least some would survive to adulthood. Furthermore, the nurturing of young sauropods was likely communal, with multiple adults watching over the younger members of the herd. This kind of social arrangement helped protect the young from predators and ensured that they learned essential survival skills. When considering their habitat, sauropods tended to inhabit lush, floodplain environments teeming with diverse plant life. This ecosystem allowed them to access abundant food sources while providing ample space for movement. The combination of their physical size and structure, alongside their social behaviors, led these magnificent creatures to become dominant herbivores of their time, marveling ancient landscapes with their majestic presence. Truly, The adaptations of sauropods illustrate the profound relationship between an organism's physical characteristics and its role in the natural world. The discovery of feathered dinosaurs has revolutionized our understanding of these prehistoric creatures. Initially, dinosaurs were often depicted as scaly beasts, similar to modern reptiles. However, with the unearthing of fossils in various parts of the world, particularly in China, we have gained significant insights into the appearance of these ancient animals. Notably, the fossils of the velociraptor and the small theropod known as Archaeopteryx, among others, show clear imprints of feathers, suggesting that feathers existed well before the emergence of birds. These findings highlight the evolution of feathers and their potential uses. Initially thought to have been used for insulation or perhaps display in mating rituals, the presence of feathers on these dinosaurs implies a more complex ancestry. That some of these species could glide or even fly elevates the profile of dinosaurs, underscoring the varied ways they adapted to their environments. This new understanding shifts our perception of dinosaurs from being solely ferocious predators to creatures with delicate features and multifaceted behaviors. Moreover, feathered dinosaurs present a continuum between traditional reptiles and modern birds. The characteristics shared between these groups include not just feathers, but also features like hollow bones and certain aspects of their skeletal structures. This highlights that birds are in fact living dinosaurs, which challenges our previous conceptions of what it meant to be a dinosaur. The link persists and grows stronger as more discoveries are made, further blending the lines between these two classifications. As paleontologists continue to study these remarkable fossils, our picture of the Mesozoic world becomes increasingly vibrant. Each new discovery adds layers to the narrative of evolution. The presence of feathers among these creatures not only alters their apparent aesthetics, but also invites us to reconsider the environmental circumstances they lived in. In doing so, it emphasizes the awe-inspiring diversity of life that once roamed our planet. Imagine waking up in a world dominated by lush greenery and towering ferns, where the sun filters through thick canopies of leaves. A typical day for a dinosaur would have begun with the gentle rustle of vegetation and the calls of other prehistoric creatures echoing in the background. Dinosaurs like the gentle Brachiosaurus would start their morning by stretching their long necks high into the treetops, searching for the tender leaves that would fuel their massive bodies. The landscape was a feast for any plant-eating dinosaur, filled with vegetation that stretched across vast, unspoiled plains. As the sun climbed higher, it would become a ritual for many dinosaurs to roam in search of food. Some, like the swift and agile velociraptor, would actively hunt in small packs, utilizing their intelligence and teamwork to catch smaller animals. Meanwhile, the enormous triceratops might be found grazing peacefully, using their specialized beaks to strip leaves from bushes. The rest of the day would be marked by foraging, constant vigilance, and interaction with others of their kind. Social behaviors, such as mating displays and establishing territories, were notable features of dinosaur life, providing a rich tapestry of interactions. Watering holes would attract a variety of dinosaurs, creating a bustling scene where species mingled. Carnivores and herbivores alike would gather, creating a vibrant ecosystem filled with life. Birds descended from dinosaurs might flitter close by, adding movement and sound. As the day progressed, it was not uncommon for larger predators to lurk in the shadows, waiting for a chance to pounce, reminding us that the life of a dinosaur often depended on discernment and survival instincts. As the sun began its descent, coloring the sky in hues of orange and purple, dinosaurs would settle down. The carnivores would retreat to their dens, while the herbivores might huddle together for safety against nighttime predators. Rest was essential, as the cycle of life in this prehistoric world demanded stamina and strength for the next day's adventures. The charm of this ancient land was not just in its towering giants, but in the daily rhythms of life, underscoring a narrative of survival, adaptation, and the majestic spectacle of nature. Dinosaurs, like many modern animals, likely used a variety of methods to communicate with one another. Vocalizations played a significant role, with many paleontologists suggesting that dinosaurs produced sounds similar to those of birds or reptiles. Some of these vocalizations could have included low rumbles, high-pitched calls, or even squawks, allowing them to convey messages over long distances. The shape of a dinosaur's skull and the structure of its throat might provide clues about its ability to produce different sounds. In addition to vocal sounds, physical displays were another crucial aspect of communication among dinosaurs. Body language, akin to modern-day animals, would have included a range of movements such as posturing, tail displays, and changes in stance. For example, some species might have flared their crests or display features during courtship rituals, helping to advertise their strength or health to potential mates. Observing how other animals, like birds and reptiles, use such displays today can give us a glimpse into the behaviors that might have been prevalent among dinosaurs. Visual communication might also have included color changes in skin or features, similar to how some modern reptiles change color to communicate their mood or intentions. Fossil evidence, such as preserved feathers or skin impressions, hints that some dinosaurs were quite colorful. Those vibrant displays could have served several purposes, from attracting mates to warning rivals or signaling alarm. Finally, the social structures of dinosaurs likely influenced their communication methods. Species that lived in groups, like herding dinosaurs, might have developed more complex communication systems. Understanding how these ancient animals shared information can help us appreciate the social dynamics of their world, reminding us that the absence of humanoid features did not preclude them from having rich and varied forms of interaction. The concept of social behavior among dinosaurs is supported by various forms of evidence, including fossilized trackways, nesting sites, and the discovery of fossilized remains found in groups. Fossilized footprints have revealed scenarios where multiple dinosaurs walked together, suggesting they may have traveled in herds or packs. These footprints often show changes in direction and clustering patterns that indicate coordination and social interaction, much like modern herd animals. In addition to trackways, evidence from nesting sites offers insight into the social behavior of dinosaurs. Some species appear to have raised their young in communal nesting grounds, where numerous nests are found clustered together. This implies that these dinosaurs may have engaged in cooperative care of their offspring, a trait seen in several present-day bird species. The arrangement of these nests suggests a level of social organization that is fascinating to consider. Moreover, paleontologists have discovered fossilized remains of dinosaurs found in large groups, providing clues about their social structures. For example, some theropod dinosaurs, closely related to modern birds, have been found in deposits suggesting they lived and hunted in packs. This social structure could have helped them during hunting, protection against predators, and the upbringing of their young. Through these various lines of evidence, ranging from footprints and nesting behaviors to the arrangement of fossilized remains, scientists unlock the door to the social lives of dinosaurs. This perspective adds depth to our understanding of these incredible creatures, painting a picture of complex interactions that may have defined their existence millions of years ago. The diets of dinosaurs played a significant role in shaping their social structures. Herbivorous dinosaurs, like the giant sauropods and the duck-billed hadrosaurs, tended to live in large herds. This was likely a strategy for survival, as moving in groups increased protection against predators. Being plant-eaters meant they needed to travel considerable distances to find food. By banding together, these dinosaurs could efficiently graze large areas while also providing safety in numbers against potential carnivore attacks. In contrast, carnivorous dinosaurs, such as Tyrannosaurus rex or Velociraptor, often had very different social dynamics. Many of these predators were solitary or lived in smaller packs. Their hunting strategies typically required stealth and agility, which was often best executed alone or with just a few companions. A solitary lifestyle allowed these meat-eaters to establish territories and reduce competition when hunting for their prey. The social interactions of these carnivores were thus geared toward hunting efficiency rather than the communal grazing seen in herbivores. Furthermore, the structure of each group's social interactions also differed. Herbivorous dinosaurs likely developed complex social behaviors, communicating in ways that facilitated group movement and alerted members to danger. This cooperative behavior fostered strong bonds within the herd, which could be crucial for nurturing young and ensuring survival amidst threats. Their social cohesion was driven by the need to remain vigilant against predators, a constant concern for these largely defenseless giants. Lastly, the environmental context further influenced these social structures. Herbivores had to contend with varying plant growth and seasonal changes, which often dictated their migratory patterns. Carnivores, on the other hand, adapted their hunting behaviors and social structures based on prey availability. Thus, both dietary needs crafted unique social systems that were intricately tied to their survival strategies, demonstrating the profound impact of food choices on the lives of these ancient creatures. In contrast, many reptiles tend to exhibit different nesting strategies. While some may lay their eggs in nests and leave them to develop independently, others may remain with their young only briefly. In this regard, dinosaurs seem to have displayed a more committed approach to parenting, much like many birds today. For example, evidence of nesting sites containing fossilized eggs and even fossilized baby dinosaurs indicates that they might have cared for their young in ways that suggest a greater social structure, somewhat akin to the family dynamics we observe in certain bird species. Interestingly, the spectrum of nesting behaviors highlights an evolutionary bridge between reptiles and birds. The transition from the ancient nesting habits of dinosaurs to those of modern birds embodies an evolutionary innovation. Many theropods, which later evolved into birds, shared physical characteristics like feathers and, importantly, a more sophisticated approach to nurturing their offspring, which showcases a significant shift in developmental strategies compared to their reptilian cousins. The study of dinosaur nesting behaviors not only informs us about their lives, but also enriches our understanding of the evolutionary lineage leading to birds. As we uncover more evidence from fossils, we gain a clearer picture of how these magnificent creatures lived, cared for their young, and contributed to the rich tapestry of life that shapes our planet today. The ties between these ancient giants and their modern descendants continue to intrigue scientists and enthusiasts alike, highlighting the remarkable story of evolution and adaptation. During the age of dinosaurs, which spanned millions of years, the Earth experienced a remarkable variety of prehistoric environments. These ranged from lush, dense forests to vast deserts, each offering different ecosystems that supported diverse forms of life. In the early Mesozoic era, the landscape was primarily dominated by broad, swampy lowlands and expansive coniferous forests. These environments provided ample food and shelter for the numerous herbivorous dinosaurs that roamed the land. As we move through the Mesozoic, we see a shift towards more tropical and subtropical climates. In certain regions like modern-day North America, there were once expansive inland seas that split land masses, creating rich coastal environments complete with vibrant marine life. These seas were teeming with fish, and dinosaurs that adapted to an aquatic lifestyle made their home here, showcasing an incredible array of evolutionary adaptations. The age of dinosaurs also witnessed the rise of arid, desert-like conditions in some areas. These environments, while harsher, developed unique ecological niches. Dinosaurs that thrived in these landscapes had to be resourceful. Some evolved characteristics that allowed them to conserve water and endure the extreme temperatures. The environment also influenced their physical attributes, with some species developing long limbs for speed to escape predators and swifter access to sparse vegetation. Overall, the variety of prehistoric environments during the age of dinosaurs shaped the evolution and behavior of these magnificent creatures. From thriving jungle canopies to serene coastlines and arid desert flats, the interplay between climate, geography, and the dinosaurs themselves created a dynamic world unlike anything we see today. Each change in environment posed new challenges and opportunities, leading to the diverse array of dinosaur species that roamed our planet millions of years ago. The geological features of the landscape during the age of dinosaurs played a crucial role in shaping their behavior and adaptations. Dinosaurs roamed a planet that was dramatically different than it is today, with varied terrains including vast plains, towering mountains, dense forests, and arid deserts. Each of these environments influenced how dinosaurs lived, interacted, and evolved to survive. For instance, the availability of water sources greatly affected dinosaur distribution. In areas with abundant rivers and lakes, herbivorous dinosaurs thrived as lush vegetation provided a steady food supply. The presence of valleys and fertile land attracted large herds, allowing for social behavior to flourish. On the other hand, in drier regions, dinosaurs had to adapt by developing behaviors to conserve water, such as migrating to find new waterholes or seeking refuge in shaded areas during the hottest parts of the day. Moreover, geological events such as volcanism and tectonic shifts created barriers and modified ecosystems. Dinosaurs were often forced to adapt to changing environments, creating an evolutionary pressure that drove the emergence of new traits. For species that lived in mountainous regions, adaptations like strong hind limbs for climbing or specialized diets to handle high-altitude flora became essential. In contrast, those in flat, open ranges evolved to sprint away from predators, leading to enhanced speed and agility. Ultimately, the interplay between geography and the dinosaurs shaped their world dramatically. Each unique environment dictated not just how they moved, but how they fed, reproduced, and socialized. As landscapes shifted and transformed, the dinosaurs had to continually adapt, resulting in the diverse array of species and behaviors we study today. Understanding this relationship helps us appreciate the resilience and complexity of life on Earth millions of years ago. Water sources played a crucial role in the distribution and lifestyle of various dinosaur species, shaping not only where they lived, but also how they thrived. In a world that was often dominated by dry landscapes, the presence of rivers, lakes, and wetlands acted as vital lifelines. These water sources provided essential hydration, a habitat for diverse ecosystems, and a vital food supply, allowing various dinosaurs to flourish. Dinosaurs that lived in close proximity to water sources were often larger and more diverse. For example, herbivorous dinosaurs, which had to consume massive amounts of vegetation, thrived near lush, water-rich areas where plant life was abundant. Species such as the long-necked sauropods are known to have frequented riverbanks and floodplains where they could reach high branches and a variety of foliage. In contrast, carnivorous dinosaurs often followed herbivores, using these water sources as hunting grounds. Waterholes and riverbanks became dynamic ecosystems where life interacted in multiple ways, facilitating a delicate balance. The presence of water also influenced migration patterns. Many dinosaurs would travel great distances to find reliable sources of water, especially in arid periods. Those that could adapt to the changing availability of water often had better survival rates, enabling them to thrive in different regions. Fossil evidence suggests that some species adapted unique behaviors tied to the necessity of water, such as forming herds that moved seasonally to exploit lush areas for feeding and hydration. The proximity to water not only dictated the location of dinosaur populations, but also their behaviors and evolutionary strategies. Water sources were more than just physical elements of the landscape. They were essential to the survival and diversity of dinosaurs, contributing to the intricate dance of life that characterized their era on Earth. Through this essential resource, we see how interconnected the ancient ecosystems were, painting a vivid picture of life long before our time. To understand the evolution of flora and fauna during the age of dinosaurs, we must first consider the climate they were living in. Ancient climates were not static. They changed over millions of years, creating diverse environments ranging from arid deserts to lush tropical forests. The Mesozoic era, often referred to as the Age of Dinosaurs, spanned from about 253 million years ago to about 66 million years ago. Throughout this time, the Earth experienced notable shifts in climate that significantly influenced the development of both plant and animal species. During the Triassic period, the climate was generally hot and dry, and the landscape was largely dominated by seasonal rains. This environment encouraged the evolution of hardy plants, such as cycads and ginkgos, which were well suited to withstand the harsh conditions. Interestingly, these plants would later serve as important food sources for many of the herbivorous dinosaurs, like the massive sauropods. As the climate began to change in the Jurassic period, with increased vegetation and rising humidity, lush forests flourished, creating a diverse habitat rich in resources. This change supported an even wider variety of dinosaurs, leading to innovations in their sizes and adaptations. The Cretaceous period introduced further advancements in flora with the rise of flowering plants. These new species provided fresh food sources and habitats, influencing the dietary habits and behaviors of many dinosaurs. Pollinators like insects adapted to these flowering plants, paving the way for a more interconnected ecosystem. The transformation in plant life encouraged diverse evolutionary paths among both herbivorous and carnivorous dinosaurs. Species learned to thrive in distinct niches, whether they were consuming leaves high in tree canopies or hunting smaller animals. The ancient climate played a crucial role in shaping the ecological dynamics of the Mesozoic, directly influencing the evolution of flora and fauna. The fluctuations in climate contributed to a vibrant tapestry of life where interdependence among species flourished. This rich interaction set the stage for the diverse and remarkable array of plants and animals that cohabitated with dinosaurs, showcasing nature's ability to adapt and thrive in response to its ever-changing environment. Natural disasters played a significant role in shaping the fate of dinosaur species during their reign on Earth. Earthquakes, volcanic eruptions, and meteor impacts inserted unpredictable forces into the ecosystems where dinosaurs thrived. These events often resulted in habitat destruction and drastic environmental changes that could threaten the delicate balance necessary for species survival. For example, massive volcanic eruptions could lead to acid rain, altered climates, and poisonous gases, all contributing to food shortages and ecological collapse. One of the most shocking events was the meteor impact that occurred around 66 million years ago, believed to have caused the extinction of the non-avian dinosaurs. This impact created immense wildfires and released a cloud of dust and debris that surrounded the Earth. The sun was blocked for an extended period, significantly reducing the amount of sunlight reaching the surface. This darkened sky caused temperatures to drop and disrupted photosynthesis, leading to a breakdown in the food chain. Plants withered, herbivores struggled to survive, and ultimately the carnivores that preyed upon them perished as well. On the flip side, some species showed remarkable resilience to environmental changes caused by natural disasters. Dinosaurs had adaptations that allowed them to survive in various habitats and climates. Certain species could migrate in search of food or better living conditions, increasing their chances of survival when local ecosystems were threatened. This ability to adapt and evolve is part of what made dinosaurs the dominant terrestrial vertebrates for approximately 150 million years. Charismatic species like the Tyrannosaurus rex and the Triceratops became symbols of this incredible diversity, but not all dinosaurs were so fortunate. The harsh realities of natural disasters taught us valuable lessons about vulnerability and adaptability in the face of change, not just for dinosaurs, but for all species, including those that walk the Earth today. Predatory dinosaurs, known as theropods, were some of the most fascinating hunters of their time. Their hunting strategies varied significantly among species, reflecting the diversity of their environments and prey. Some theropods, like the formidable Tyrannosaurus rex, developed incredible sensory adaptations that allowed them to detect potential prey, honing in on movement and sounds. This keen sense of smell, much like that of modern predatory birds, helped them locate animals even from a distance. Many hunting strategies involved ambush tactics. Smaller theropods, such as Velociraptor, often relied on speed and agility, allowing them to quickly close in on unsuspecting prey. Their sharp claws and teeth were designed for slashing and gripping, making them efficient hunters. Some scientists suggest that these smaller dinosaurs might have even hunted in packs, coordinating their movements to take down larger animals. This group strategy would have increased their chances of success and showcased their ability to work collaboratively. Larger predators, on the other hand, often adopted a different approach. They relied on sheer power and size to intimidate or overpower their prey. Some species, such as Allosaurus, are believed to have employed a tactic of chases, using their speed to tire out their quarry before making the final powerful strike. This combination of physical prowess and strategic planning made them effective hunters in their own right. The methods of predatory dinosaurs offer a remarkable insight into the complexities of prehistoric ecosystems. By studying their bone structures and traces left in the fossil record, paleontologists can piece together how these ancient predators were sculpted by the demands of their environment, ensuring they remained at the top of the food chain. Each hunting method not only reveals the capabilities of these incredible creatures, but also paints a picture of the dynamic and often brutal world they navigated. Herbivorous dinosaurs faced numerous threats from predators during the Mesozoic era, leading them to evolve a fascinating array of defensive mechanisms to survive. One of the most iconic adaptations is size. Many herbivorous dinosaurs grew to enormous lengths like the sauropods, whose massive bodies made them less appealing to smaller predators. This sheer size acted as a formidable barrier. Few dinosaurs could take on such colossal creatures. In addition to size, these dinosaurs developed physical features that enhanced their defenses. Many had robust, armored bodies such as the stegosaurs, which boasted plates and spikes along their backs and tails. These bony structures served not only as a deterrent to would-be attackers, but also as a means to assert dominance within their own species. The spikes could inflict serious damage if swung in defense, making those dinosaurs a dangerous target. Another clever adaptation was the development of herd behavior. Many herbivorous dinosaurs roamed in groups, which provided safety in numbers. This communal living allowed them to watch for predators collectively, effectively minimizing individual risk. When threatened, they could band together, using their size and strength to fend off attackers or even confuse them with their sheer numbers. Finally, some herbivorous dinosaurs adopted quick escapes as a strategy. Dinosaurs like the ornithopods were built for speed, enabling them to flee from predators at a moment's notice. Combined with keen senses and the ability to navigate their environments quickly, these defensive tactics highlight the ingenuity and resilience of herbivorous dinosaurs in the face of constant predation. Through size, armor, social behavior, and speed, they crafted a diverse toolkit for survival that showcases nature's adaptability. The fossil record serves as a remarkable window into the ancient ecosystems that existed millions of years ago, particularly shedding light on the predator-prey relationships among dinosaurs. As paleontologists uncover fossils, they often find the remains of both predators and their prey within the same sedimentary layers. This timing offers clues about the interactions and dynamics of these long-standing relationships. One of the key methods scientists use is examining the characteristics of the fossils. Predatory dinosaurs often exhibit features such as sharp teeth and claws, adaptations that reflect their role as hunters. In contrast, herbivorous dinosaurs might show flat teeth suited for grinding plants, alongside strong limbs for escape. Fossils that display bite marks or tooth impressions on prey bones provide direct evidence of predation. Such markings show how predators engaged with their prey, indicating which species were vulnerable at certain times. Additionally, the analysis of fossilized dung, known as coprolites, offers more insight into these ancient interactions. When scientists study the contents of coprolites, they can identify the undigested remains of prey animals, revealing not just what these predators consumed, but also the diversity of species that coexisted. This information enables scientists to reconstruct food webs and understand which dinosaurs competed for similar resources. Furthermore, the distribution of various dinosaur fossils can hint at geographical factors influencing predator-prey dynamics. For instance, fossils found in certain locations may suggest that predators had preferred hunting grounds, or that specific environments provided refuge for prey species. Overall, the fossil record is a treasure trove of information, helping us piece together the complex interplay between these magnificent creatures as they thrived in their prehistoric worlds. Camouflage and mimicry were crucial aspects of survival for many dinosaurs, helping them navigate a world filled with predators and competition. For herbivorous dinosaurs, blending into their environment likely offered an effective strategy for avoiding detection. Take the example of large sauropods, with their gigantic bodies covered in patterns that mimicked their surrounding vegetation. This natural disguise could have helped them escape the keen eyes of carnivorous dinosaurs who relied heavily on sight to hunt their prey. For smaller dinosaurs, especially those that lived in forested areas, colors and patterns that matched the foliage would offer significant protective benefits. The ability to hide in plain sight could mean the difference between life and death, allowing these dinosaurs to forage for food while staying hidden from potential threats. This idea of camouflage extends beyond surface appearance. Many dinosaurs might have used behavior to enhance their cover, from remaining still to adopting certain postures that made them less visible. Mimicry, on the other hand, presented another fascinating survival strategy. Some dinosaurs might have evolved to resemble other more dangerous or unpalatable species. For instance, a smaller dinosaur that mimicked the appearance or behavior of a much larger, more threatening one could discourage predators from approaching. This psychological tactic would serve as an additional layer of defense, fooling attackers into thinking that their potential meal was much more formidable than it truly was. Moreover, color patterns and textures could also play a role in communication among peers. Dinosaurs may have used visual signals for mating rituals, social interactions, or establishing dominance. The complexity of these strategies reveals a rich tapestry of evolutionary survival tactics at play during the age of dinosaurs, showcasing their adaptability in an ever-changing environment filled with challenges. As we continue to study these magnificent creatures, the ways they lived and thrived in their ecosystems remind us not only of their struggles, but also of the intricate balance of nature. Pack hunting behaviors in certain species of carnivorous dinosaurs represent a fascinating evolutionary strategy that likely developed in response to their environment and social structures. Instead of hunting alone, these dinosaurs would work together, enabling them to take down larger prey than they could tackle individually. This dramatic shift towards cooperative hunting could have emerged from the pressures of survival, such as the need for increased food resources or protection against larger predators. Fossil evidence suggests that some species, like the famous Deinonychus and the larger Allosaurus, showed signs of social interaction. Teeth marks and bite patterns found on remains of prey animals indicate that multiple individuals often participated in the hunt. This coordinated approach not only allowed for the capture of bigger animals, but also spread the risk during dangerous confrontations. The dynamics of teamwork meant that these carnivorous dinosaurs could use strategic tactics, like encircling or trapping their prey, making them more effective hunters. Beyond just physical advantages, pack hunting may have fostered social bonds among members of the group. By living and hunting in packs, these dinosaurs could develop complex social structures. Such relationships could enhance mutual cooperation, leading to improved survival rates for the group. These social interactions might also have provided a way for younger or less experienced members to learn essential hunting skills, ensuring the survival of the species. Ultimately, the evolution of pack hunting behaviors in carnivorous dinosaurs illustrates the intricate balance between survival, cooperation, and adaptation to their changing world. These social strategies not only allowed them to thrive in diverse ecosystems, but also reflected the advanced evolutionary features that would continue to influence predator-prey dynamics long after their time on Earth. The legacy of such behaviors still resonates in the animal kingdom today, reminding us how interconnected life can be, even in the challenges of the prehistoric past. Fossils have played a pivotal role in unraveling the mysteries of dinosaur anatomy and behavior. Among the most significant types of fossils are bone fossils, which provide a direct glimpse into the skeletal structure of these magnificent creatures. Paleontologists examine the size, shape, and density of bones to understand everything from the weight and height of dinosaurs to their locomotion. By comparing bones across various species, researchers can identify characteristics such as whether a dinosaur was bipedal or quadrupedal. In addition to skeletal remains, trace fossils have emerged as key indicators of dinosaur behavior. These include footprints, which offer remarkable insights into how dinosaurs moved and interacted with their environment. For instance, the size and depth of a footprint can suggest the weight and speed of a dinosaur, while patterns in closely spaced footprints may indicate social behavior, such as herding or parental care. Fossilized nests and eggs provide important clues about reproductive behaviors and nesting habits, revealing the care and nurturing strategies of different species. Another fascinating type of fossil is the study of coprolites, or fossilized dung, which helps scientists understand the diet and digestive processes of dinosaurs. Analyzing these fossils can reveal what various species ate, depending on whether they were herbivores, carnivores, or omnivores. This provides a window into the ecosystem dynamics and food chains of the past, painting a vivid picture of how dinosaurs interacted with their environment. Finally, soft tissue fossils, although rare, have garnered great attention. These exceptional discoveries can include skin impressions and even traces of blood vessels, offering unprecedented details about the physical characteristics and coloration of dinosaurs. Together, these various types of fossils form a rich tapestry, allowing us to construct a more comprehensive understanding of dinosaur anatomy and behavior, bringing these ancient giants to life in our imaginations. Paleontologists have developed several techniques to determine the age of dinosaur fossils, a crucial aspect of understanding the history of life on Earth. One of the primary methods they use is radiometric dating. This technique relies on the decay of radioactive isotopes found in rocks surrounding the fossils. As these isotopes break down over time, they emit particles and radiation, allowing scientists to calculate how long it has been since the rock formed. By measuring the abundance of these isotopes, along with their decay products, paleontologists can establish a reliable time frame for when the fossils were created. Another key method involves examining the stratigraphy of sedimentary layers in which fossils are discovered. Sedimentary rocks are often layered, and these layers, or strata, provide a chronological sequence of deposition. By analyzing the arrangement of these layers, researchers can make educated estimates about the age of the fossils contained within them. This method works particularly well when fossils are located in well-preserved geological formations, enabling scientists to correlate ages based on localities with known timelines. The context in which fossils are found also plays a significant role in determining their age. Paleontologists often utilize the concept of biostratigraphy, which involves using the presence of particular fossils known as index fossils. These are species that existed for a relatively short and well-defined period. By identifying these index fossils within sediment layers, scientists can create a relative dating framework, linking different locations based on similar fossil content. Finally, other techniques like thermoluminescence and electron spin resonance can also contribute to dating fossils. These methods are useful for dating materials that may not contain organic material, extending the capabilities of paleontologists to understand and piece together the timelines of various regions where dinosaurs once roamed. Together, these approaches enable paleontologists to reconstruct the grand timeline of Earth's history and the age of its remarkable prehistoric inhabitants. Dinosaur paleontology has unveiled some extraordinary discoveries that have reshaped our understanding of these magnificent creatures. One of the most groundbreaking findings was the discovery of dinosaur feathers. Initially, paleontologists believed that dinosaurs were more akin to reptiles, but the unearthing of feathered fossils, particularly in regions like China, revealed a closer connection to modern birds. This shifted our perspective on the evolution of flight and hinted that many dinosaurs were not just scaly giants, but had complex behaviors and appearances. Another significant discovery is the identification of dinosaur nests and their young, suggesting that many species exhibited nurturing behaviors. Sites filled with fossilized eggs have provided crucial insights into the reproductive habits of dinosaurs. This evidence not only illustrated that some dinosaurs cared for their young, but also offered a glimpse into their social structures. It suggests that the bonds formed by these creatures were more intricate than previously understood, adding depth to our view of their lives. The revelation of mass extinction events has also played a critical role in paleontology. By studying geological layers, scientists have identified periods where large populations of dinosaurs disappeared. The most famous is the event roughly 66 million years ago, believed to be caused by a colossal asteroid impact. Understanding these catastrophes is vital as they inform us about the resilience of life on Earth and how ecosystems recover from such profound disruptions. Lastly, the technological advancements in paleontology, such as computerized tomography and digital scanning, have opened new frontiers. These methods allow researchers to examine fossils without causing damage, revealing internal structures that were previously invisible. As a result, we gain an even clearer image of how dinosaurs lived, grew, and evolved. Each discovery helps weave together the rich tapestry of Earth's history and our place within it, making dinosaur paleontology continually exciting and relevant. Recent advancements in technology, particularly in imaging techniques like computed tomography scanning, are revolutionizing our understanding of dinosaur fossils. Traditionally, paleontologists relied on physical examinations and basic imaging to study these ancient remains. However, Kinetic scanning allows us to visualize the insides of fossils without damaging them, revealing intricate structures that were previously hidden from view. This non-invasive technique offers a new window into the lives of dinosaurs, providing a better understanding of their anatomy and biology. CT scanning works by taking multiple X-ray images from different angles and then compiling them into a three-dimensional model. This means scientists can explore the internal structures of bones, such as the density and arrangement of various tissues. For instance, researchers have been able to identify characteristics in dinosaur bones that suggest how they moved or lived. By examining the development of their skeletal features, scientists can infer details about their growth patterns and social behaviors, enriching the narrative of how these magnificent creatures existed millions of years ago. Moreover, kinetic scanning paves the way for discoveries beyond just the bones. In some cases, it has revealed the presence of soft tissues, including traces of feathers and internal organs, which give us deeper insights into the evolutionary relationship between dinosaurs and modern birds. These findings challenge our preconceived notions about the appearance and functionality of dinosaurs, offering a glimpse into their complexity and diversity. As technology continues to advance, the potential for new discoveries remains limitless. With systems becoming more sophisticated, scientists can now create highly detailed reconstructions of fossilized remains. This not only enhances our understanding of dinosaurs themselves, but also paints a vivid picture of the ecosystems they inhabited. Through these high-tech explorations, we are gradually uncovering the mysteries of our planet's distant past, and with each finding, our fascination with these extraordinary creatures grows even deeper. Sediment analysis plays a crucial role in piecing together the environments where dinosaurs once roamed the Earth. By examining the layers of sediment, scientists can uncover valuable information about ancient ecosystems. Each layer tells a story, recording details about the climate, geography, and even the types of vegetation that existed millions of years ago. This sediment can range from fine silt to larger grains of sand, each indicating different environmental conditions. When scientists analyze these sediment layers, they look for various indicators like fossilized plant material, pollen, and the minerals present. The presence of certain sediments can reveal if the area was once a lush forest, a dry desert, or even a shallow sea. For instance, finding a layer rich in clay could suggest a floodplain, while sandstone might indicate a windy, arid landscape. These clues allow researchers to recreate the habitats that dinosaurs inhabited, giving us insight into their lives and behaviors. Moreover, sediment analysis also helps in understanding climatic shifts over time. By studying how the composition and type of sediment change through different layers, scientists can gauge periods of warming or cooling. This is vital for understanding how dinosaurs adapted to their environments, or even how shifts in climate may have contributed to their extinction. It paints a broader picture of the dynamic relationship between these creatures and the Earth's changing landscapes. Sediment analysis serves as a time capsule, capturing the myriad changes that have occurred on our planet. By unlocking these secrets, scientists can better understand not only the dinosaurs themselves, but also the intricate ecosystems they once thrived in, deepening our appreciation of life on Earth during that fascinating era. The mass extinction event that wiped out the dinosaurs around 66 million years ago remains one of the most captivating subjects in scientific inquiry. The most widely accepted theory attributes this event to a colossal asteroid impact. This theory gained significant traction after the discovery of a layer of iridium-rich clay in the geological record, particularly at a site in the Yucatan Peninsula known as the Chicxulub crater. Iridium is rare on Earth's surface but abundant in asteroids, suggesting that a massive impact could have released enough energy to cause catastrophic environmental changes. In addition to the asteroid theory, another explanation involves extensive volcanic activity, particularly in what is today known as the Deccan Traps in India. These massive volcanic eruptions would have unleashed vast amounts of ash and gas into the atmosphere, leading to a series of environmental disruptions. The resulting climate change could have caused a significant drop in temperatures and altered rainfall patterns, dramatically affecting the habitats of various species, including dinosaurs. Some scientists argue that these two catastrophic events might not have occurred in isolation. Instead, the volcanic eruptions could have contributed to the global consequences already initiated by the asteroid impact. Such cosmic and terrestrial calamities could have interacted in complex ways, creating a chain reaction that devastated ecosystems and eliminated food sources for the dinosaurs. Adding another layer of complexity, researchers are exploring the role of gradual environmental changes leading up to this mass extinction, such as shifts in sea levels, changing temperatures, and evolving ecosystems. These changes could have stressed the dinosaur populations, making them less resilient to the sudden catastrophic events of the asteroid impact and volcanic eruptions. Each hypothesis offers a piece of the puzzle, fueling our fascination with one of Earth's most dramatic chapters in natural history. The meteor impact theory offers a compelling explanation for the dramatic environmental shifts that coincided with the extinction event around 65 million years ago. This theory suggests that a massive meteor, estimated to be approximately 10 kilometers in diameter, collided with Earth, creating a cataclysmic event. The impact generated an immense amount of energy, equivalent to billions of atomic bombs. This explosion triggered a series of changes that profoundly affected the planet's climate and ecosystems. In the aftermath of the impact, the initial explosion vaporized a significant amount of material from the Earth's surface and sent debris soaring into the atmosphere. This debris created a cloud of dust that encircled the planet, blocking sunlight for an extended period. As a result, temperatures plummeted in a phenomenon often referred to as impact winter. This sudden drop in temperature disrupted photosynthesis, which in turn affected the entire food chain. The plants that provided sustenance for herbivores died off, leading to a cascading effect that ultimately impacted predator species. Moreover, the energetic impact also released sulfur and carbon dioxide into the atmosphere. Sulfuric gases combined with moisture, leading to acid rain, further compromising the environment. The buildup of carbon dioxide eventually led to a greenhouse effect, which caused global temperatures to rise again after the initial cooling. This cycle of extreme temperature fluctuations created an inhospitable environment for many species, especially large dinosaurs and other life forms that could not adapt quickly enough to the rapid changes. Overall, the meteor impact theory paints a picture of an Earth thrown into turmoil, where ecosystems that took millions of years to develop were dramatically altered in the blink of an eye. This catastrophic event reshaped life on Earth and paved the way for the rise of mammals and eventually the evolution of humans. The science behind this theory continues to evolve, but it captivates our understanding of how interconnected and fragile life truly is in the face of cosmic events. The idea that volcanic activity played a critical role in the extinction of the dinosaurs is supported by detailed geological and paleontological studies. Among the most compelling evidence comes from the Deccan Traps in what is now India. This vast region is characterized by extensive layers of solidified lava that erupted around the time of the dinosaurs' extinction, approximately 66 million years ago. The colossal scale of these eruptions suggests that they released a significant amount of ash and gas into the atmosphere, which would have had profound effects on the planet's climate. When these ash and gases, particularly sulfur dioxide and carbon dioxide, were released into the atmosphere, they likely caused dramatic changes in the weather patterns. Sulfur dioxide, for example, can form sulfuric acid clouds, leading to short-term global cooling. This cooling would create harsh environments for many species, disrupting the fossil record of plant life and food chains, essentially affecting the entire ecosystem in which dinosaurs thrived. It is thought that such rapid climate changes would have been incredibly difficult for many species to adapt to. Further supporting this theory is the evidence of fossilized plants showing a decline in diversity and abundance coinciding with the timing of these volcanic eruptions. Analyzing the sediment layers, scientists have found a pattern of extinction in various species of both flora and fauna, indicating the disruptions were widespread and severe. The volcanic activity would have not only affected the climate, but also led to acid rain and other environmental changes that would degrade ecosystems. In addition to the geological evidence, computer models have simulated the effects of these volcanic eruptions on the Earth's climate, showing that the resulting environmental changes align with the patterns of extinction seen in the fossil record. While this volcanic activity does not singularly account for the demise of the dinosaurs, other factors like asteroid impacts also played a part. It paints a clear image of a world undergoing significant turmoil. The combination of volcanic eruptions and their ecological impact likely created a perfect storm that contributed to the catastrophic end of the age of dinosaurs. The aftermath of the extinction event, often referred to as the Cretaceous-Paleogene extinction, marked one of the most significant turning points in the history of life on Earth. This event, which occurred around 66 million years ago, is best known for the dramatic demise of the dinosaurs. Over a period of millions of years, a vast environment reshaped itself, providing new opportunities for the surviving species to thrive, particularly mammals. As the dinosaurs vanished, they left behind a variety of ecological niches that needed to be filled. Before this extinction, mammals existed mostly in small, nocturnal forms, living in the shadows of their reptilian counterparts. With the dinosaurs gone, mammals suddenly found themselves with a wealth of new habitats and resources available to them. This opened the door for diversification, allowing mammals to evolve into a range of sizes, shapes, and dietary strategies. This period of recovery, known as the Paleogene era, saw mammals begin to adapt rapidly. Species that had once been largely overshadowed blossomed into forms that allowed them to occupy roles previously held by dinosaurs. From the tiny insectivores scampering under the cover of darkness to the colossal herbivores grazing in wide-open fields, mammals adapted to their environments in ways that were previously unimaginable. Ultimately, this extinction event served as a catalyst for the evolution of mammals. Freed from the competition with dinosaurs, they rapidly diversified, and given enough time, mammals evolved into the vast array of species we see today, including the ancestors of modern humans. This remarkable narrative of loss leading to rebirth and transformation underscores the dynamic nature of life on Earth and the unexpected turns that evolution can take. The survival of certain species after mass extinction events offers profound insights into resilience and adaptation. One of the most striking examples comes from the aftermath of the dinosaur extinction around 66 million years ago. While a vast number of species perished, some creatures, particularly small mammals, managed to thrive in the changed environment. This indicates a remarkable ability to adapt to new conditions, showcasing how flexibility in behavior and diet can lead to survival when faced with adversity. Resilience in surviving species can often be attributed to a few key traits. Take, for instance, their reproductive strategies. Many surviving species tend to have high reproductive rates, allowing them to recover their populations quickly after drastic declines. Additionally, some animals are incredibly versatile eaters, which means they can adjust their diets depending on what resources are available. This adaptability is a crucial element that enables them to cope with shifting habitats and changing climates. Another fascinating aspect is the role of genetic diversity. Populations with a greater variety of genetic traits are often better equipped to withstand environmental stress. When faced with challenges like limited food or new predators, some individuals may possess traits that give them an edge, whether it's foraging skills or resistance to disease. This genetic toolkit becomes vital when the environment undergoes significant changes, as it increases the chance that some members of the population will thrive. Overall, the continued existence of some species after extinction events serves not just as a lesson in survival, but as an inspiration for all living beings. It teaches us that resilience is not about avoiding hardship. Rather, it's about adapting and finding new ways to exist in a world that is constantly changing. The story of survival is often a story of change, and observing how life persists can deepen our understanding of both nature and our place within it. Dinosaurs have undeniably left a profound mark on modern culture, permeating various forms of artistic expression from literature to film. One of the earliest literary depictions of these ancient creatures appeared in the 19th century, with works inspired by the scientific discoveries of the time. Authors like Sir Arthur Conan Doyle, in his novel The Lost World, transported readers to a land where prehistoric giants roamed, igniting the public's imagination around these magnificent reptiles. This fascination laid the groundwork for countless stories that explore human encounters with dinosaurs, often blending adventure, science fiction, and fantasy. As we moved into the late 20th century, dinosaurs truly roared to life on the big screen. Steven Spielberg's iconic film, Jurassic Park, released in 1993, not only showcased groundbreaking visual effects, but also captured the hearts of millions. This cinematic milestone reinvigorated interest in dinosaurs, merging scientific concepts with thrilling narratives. The film's success led to a series of sequels, spin-offs, and a resurgence in paleontological studies, demonstrating how a single film can reshape cultural perception and knowledge about these ancient beings. Beyond film, dinosaurs have also made their mark on television, video games, and even advertising. Animated shows like The Land Before Time introduced younger audiences to the wonders of dinosaurs, while educational programs have sought to inform and inspire a passion for paleontology. Video games, from immersive simulations to adventure platforms, have allowed players to interact with and learn about these creatures in engaging ways. Meanwhile, dinosaurs have become popular symbols in marketing, capitalizing on their universal appeal to evoke wonder and nostalgia. In literature, the fascination continues with a range of children's books, scientific texts, and even novels exploring themes of evolution and extinction. The diversity of dinosaur representation across these platforms reflects not only our scientific understanding, but also our ever-evolving relationship with these ancient creatures. As they continue to captivate our imagination, dinosaurs serve as a bridge connecting us to our remote past, reminding us of both the majesty of life that once existed and the fragility of our current existence. Museums serve as vital gateways to the past, especially when it comes to the fascinating world of dinosaurs. They are more than mere collections of fossils. They are educational hubs that inform and inspire visitors about these ancient creatures and the ecosystems they inhabited. Through meticulously crafted exhibits, museums provide a tangible connection to the distant past, allowing the public to visualize what the Earth looked like millions of years ago. One of the key roles of museums is to showcase impressive displays of dinosaur skeletons, models, and replicas. These exhibits often incorporate detailed information about the size, behavior, and evolutionary history of various species. By using lifelike recreations and dioramas, museums spark the imagination of visitors, bridging the gap between scientific fact and storytelling. This immersive experience helps people understand the scale of these animals and their importance in the history of life on Earth. Additionally, many museums conduct educational programs and workshops aimed at different age groups. These programs often include hands-on activities, interactive displays, and lectures by paleontologists, which deepen the understanding of dinosaur biology and paleontology. For children and families, these engaging activities can ignite a passion for science and nature, fostering a new generation of thinkers and explorers who appreciate the wonders of our planet's history. Moreover, museums play a critical role in ongoing dinosaur research and preservation. They often collaborate with universities and research institutions, providing a platform for new discoveries to be shared with the public. By adopting modern technology, such as virtual reality and digital exhibits, museums enhance the learning experience, making it more accessible and enjoyable. Through their multifaceted approach, museums not only educate the public about dinosaurs, but also cultivate an enduring sense of curiosity about the natural world. Fictional representations of dinosaurs in movies, television shows, books, and other forms of media have significantly shaped how the public perceives these magnificent creatures. For many, the first introduction to dinosaurs often comes from blockbuster films like Jurassic Park, where the majestic and terrifying aspects of these ancient reptiles are brought to life with cutting-edge special effects. This kind of portrayal captivates the imagination but can also lead to misconceptions about how dinosaurs actually lived and behaved. In these fictional narratives, dinosaurs are often depicted as fearsome predators or enormous herbivores, which highlights their size and strength. However, this portrayal can overshadow the complexity of dinosaur biology and behavior. For instance, while some dinosaurs were indeed massive and fierce, many were small and agile, with diverse lifestyles that included social behaviors, nesting practices, and even parental care. The sensationalized versions of dinosaurs often lack the nuance of scientific discovery, which has revealed that these creatures had a wide range of adaptations that helped them thrive in varied ecosystems. Additionally, fictional depictions can reinforce stereotypes, such as the idea that all dinosaurs were slow and lumbering. Movies often utilize dramatic chase scenes featuring large, menacing dinosaurs, which can lead to the common belief that these creatures were predominantly terrifying beasts. In reality, paleontological studies have shown that some dinosaurs were remarkably fast and skilled at evasion. This gap between fiction and scientific reality can influence the way younger generations understand paleontology and evolution. As audiences engage with these fictional representations, there's a unique opportunity for education. Documentaries, books, and educational programs can use popular culture references to pique interest, bridging the gap between excitement and scientific accuracy. By doing so, we can encourage a deeper appreciation for the real-world evidence that reveals the fascinating lives of dinosaurs, fostering a sense of wonder while promoting critical thinking about the natural world. Children's books and educational materials play a crucial role in sparking fascination with dinosaurs among young audiences. Through vibrant illustrations, engaging narratives, and relatable stories, these resources present dinosaurs not just as ancient creatures, but as characters with personalities and adventures. Picture books often feature colorful, larger-than-life images that capture the imagination, making it easy for children to visualize these magnificent beasts roaming the earth. Educational materials such as interactive apps and documentaries aimed at younger viewers help to translate complex scientific ideas into digestible snippets. They introduce young minds to concepts such as prehistoric habitats, diets, and behaviors through fun quizzes, games, and animations. This interactive approach keeps children engaged and encourages them to explore the topic further, transforming what could be dry facts into an adventure of discovery. Additionally, many children's books incorporate storytelling elements that resonate with kids. They create narratives where dinosaurs embark on quests, make friends, or face challenges. These stories often teach valuable lessons about friendship, courage, and curiosity, intertwining entertainment with education. Such narratives help young readers form connections with the subject matter, fostering not only enjoyment, but also a foundation of knowledge about prehistoric life. As children grow and develop more sophisticated interests, many educational materials evolve as well. They introduce topics such as paleontology and the fossilization process through captivating narratives or even hands-on learning experiences. This blend of storytelling and scientific education ensures that the wonder of dinosaurs continues to thrive in the hearts and minds of future generations, nurturing a lifelong love for learning and understanding the natural world. The portrayal of dinosaurs in different societies reflects a rich tapestry of cultural beliefs, artistic traditions, and historical contexts. Across the globe, these ancient creatures have been interpreted through various lenses, each shaped by local folklore, mythology, and scientific understanding. For instance, in Western cultures, dinosaurs are often depicted as massive, fearsome predators in films and literature, evoking a sense of awe and fear. This portrayal is tied to a fascination with scientific discovery, especially in the wake of dinosaur fossils being unearthed in the 19th century. In contrast, some indigenous cultures have woven dinosaurs into their mythological narratives, presenting these creatures in ways that connect them to the natural world and spiritual beliefs. For example, stories may feature dinosaur-like beings that share qualities with animals or humans, emphasizing respect for nature and the interconnectedness of all living things. This perspective often highlights a more harmonious relationship with the environment, contrasting with the more aggressive depictions found in popular media. Cultural differences also extend to how nations prioritize paleontological research and education. In regions where dinosaurs are a significant part of the cultural identity, such as in parts of China, public interest is often piqued through museums and educational programs, celebrating dinosaurs as symbols of national pride and scientific achievement. Conversely, in some countries, dinosaurs may be largely absent from popular culture, reflecting different societal focuses and understandings of historical life forms. Moreover, the art and literature inspired by dinosaurs can vary dramatically based on cultural values. Asian art may portray dinosaurs with a focus on beauty and wisdom, integrating them into intricate designs that convey philosophical concepts. Meanwhile, Western portrayals might emphasize raw power and competition, showcasing these creatures in dramatic, action-packed sequences. Ultimately, the way dinosaurs are visualized and understood reveals much about human culture, exploring themes of existence, fear, reverence, and the enduring quest for knowledge in our ever-evolving understanding of the past. Scientists are embarking on groundbreaking research initiatives that delve into the genetics of modern birds to uncover the evolutionary links to their dinosaur ancestors. Birds are the direct descendants of theropod dinosaurs, a group that includes the fearsome Tyrannosaurus rex and the swift velociraptor. To trace these connections, researchers are studying the genetic makeup of birds, seeking to pinpoint specific traits that have persisted or evolved over millions of years. One fascinating aspect of this research involves comparing the DNA of modern birds with that of ancient birds and dinosaur fossils. By sequencing and analyzing the genomes of a diverse array of bird species, scientists can identify genetic traits that may have emerged during the transition from dinosaurs to birds. This includes characteristics like feathers, flight mechanisms, and even changes in body size. Each piece of genetic data sheds light on how these remarkable adaptations developed and how they link back to the rich lineage from which modern birds have sprung. Another avenue of exploration is the genetic study of developmental processes in birds. By understanding how genes control the development of various physical traits in birds today, researchers can infer how similar processes may have occurred in their dinosaur ancestors. This involves looking at the embryonic development of birds, examining how structures like wings and beaks emerge, and what that reveals about prehistoric species that roamed the earth long before birds took to the skies. In addition, collaborative projects involving paleontologists and geneticists are yielding insights into extinct bird species and their close relatives. By reconstructing the evolutionary tree of life and using advanced technologies like CRISPR to edit specific genes, researchers can simulate evolutionary changes. This not only enhances our comprehension of bird evolution, but also deepens our understanding of the dynamic relationship between genetics, environment, and evolution throughout history. It's an exciting time for the intersection of genetics and paleontology, as each discovery brings us a little closer to uncovering the mysteries of our feathered friends and their ancient origins. The study of dinosaur paleontology has profoundly enriched our understanding of evolution, reshaping how we perceive the development of life on Earth. Dinosaurs, which roamed the planet millions of years ago, offer a fascinating glimpse into the evolutionary processes that shaped not only their own lineage, but also the lineage of modern birds and reptiles. As paleontologists unearth new dinosaur fossils and analyze their anatomical features, they unearth clues that highlight the intricate connections between extinct species and their living descendants. Recent discoveries have revealed a remarkable diversity in dinosaur morphology and behaviors, indicating that evolution was a dynamic process marked by adaptation to changing environments. For instance, the identification of feathered dinosaurs illustrates that birds are in fact modern-day descendants of theropod dinosaurs, reshaping our understanding of how traits evolve over time. Such evidence demonstrates that what we often think of as a linear progression in evolution is, in reality, a complex and branching tree of life, where traits can emerge, vanish, or reappear under different circumstances. Moreover, advances in technology have enhanced our ability to study fossils in unprecedented detail. Techniques like computed tomography and isotopic analysis allow scientists to peer beyond the physical structure of fossils, revealing insights into the biology and ecology of dinosaurs. This refined understanding of dinosaur physiology, habitat, and their responses to climate change deepens our appreciation for the adaptability of life and how environmental pressures can shape evolutionary pathways. As paleontologists continue to uncover new findings, our concept of evolution grows richer and more nuanced. Each discovery not only fills in the gaps of our knowledge about dinosaurs, but also encourages us to consider the broader implications for all of life on Earth. Ultimately, the story of dinosaurs is a testament to the power of evolution, illustrating how life has continuously adapted and transformed across countless generations amidst changing environments and challenges, a story that is still unfolding today. Public interest in dinosaurs has a profound influence on funding for paleontological research. These magnificent creatures, which roamed the earth millions of years ago, capture the imagination of people of all ages, sparking a curiosity that often transcends generations. This fascination translates into a robust demand for exhibitions, educational programs, and media productions, all of which can generate significant revenue. As museums and educational institutions recognize this interest, they allocate resources to increase engagement through displays and outreach, thereby creating a thriving ecosystem around dinosaur study. The allure of dinosaurs also plays a crucial role in attracting grants and donations. Foundations and corporate sponsors are more inclined to support projects that promise to captivate audiences. When paleontologists present their research with a focus on these prehistoric giants, they often find it easier to secure funding. This interest can lead to ambitious projects, such as major excavation sites or advanced research initiatives, as stakeholders see the potential for public engagement and educational value. Moreover, the media's portrayal of dinosaurs, through documentaries, movies, and television shows, brings paleontology into the public eye. This visibility not only stokes fascination, but also helps communicate the importance of scientific endeavors in this field. When people see exciting discoveries, or understand the significance of these findings in the broader context of Earth's history, they become advocates for continued research and funding. Ultimately, the intersection of public interest and scientific exploration creates a powerful dynamic. By fostering a sense of wonder about dinosaurs, society invests not only in the pursuit of knowledge, but also in the preservation of our planet's paleontological heritage. This relationship ensures that the study of dinosaurs remains vibrant, potentially leading to groundbreaking discoveries that could reshape our understanding of life on Earth. The study of dinosaurs may seem far removed from contemporary conservation efforts, yet the two fields share a foundational principle: understanding how species adapt to their environments over time. By examining fossils, scientists learn not only about the biology and behavior of these ancient creatures, but also about ecosystems at large and their resilience to changes. This knowledge becomes invaluable when addressing the challenges faced by endangered species today. Historically, the extinction of dinosaurs teaches us important lessons about vulnerability. The mass extinction events that wiped out these prehistoric giants highlight how environmental changes, such as climate shifts and catastrophic events, can drastically alter ecosystems. By recognizing the signs of stress in past environments, conservationists can better understand current ecosystems' fragility and the potential impacts of climate change, habitat destruction, and human interference on today's wildlife. Additionally, studying the dynamics of ancient species can reveal patterns of survival and extinction, providing a framework for modern conservation strategies. For example, researchers analyze how certain species thrived in changing conditions or how others could not adapt. With this information, conservationists can develop targeted strategies to bolster resilience in endangered species, offering insights into habitat protection and restoration efforts that mimic natural evolutionary processes. The lessons learned from dinosaurs extend beyond the past and profoundly influence present-day practices. By connecting these ancient narratives to current challenges, we not only honor the legacy of these magnificent creatures, but also arm ourselves with the knowledge necessary to protect the diverse life forms that share our planet today. The extinction of the dinosaurs, about 65 million years ago, offers critical insights into our current environmental challenges. This catastrophic event, widely believed to have been spurred by a colossal asteroid impact, fundamentally altered Earth's ecosystems. The aftermath reshaped life on our planet, illustrating how sudden changes can lead to both widespread destruction and opportunities for new species emergence. One of the key lessons from this significant extinction event is the impact of environmental change on biodiversity. The dinosaurs thrived in a stable climate, and their sudden eradication highlights how sensitive ecosystems can be to disruptions. Today, as we face climate change, habitat destruction, and pollution, we are reminded that the intricate balance of our current ecosystems is fragile. A small shift in temperature or habitat can lead to significant losses in biodiversity, as seen with the decline of various species across the globe. Another critical takeaway is the resilience of life. While the dinosaurs faced extinction, their demise allowed mammals to flourish, evolving into the diverse range of species we see today. This teaches us that while extinction is tragic, it can also pave the way for new beginnings. Modern environmental efforts can focus on conservation and restoration, ensuring that even in the face of challenges, we foster environments that support diverse life rather than leading to extinction. Lastly, this historical moment encourages us to be proactive rather than reactive. The lessons learned from the past emphasize the importance of understanding our environment and making informed decisions. As we confront modern challenges, we can strive to implement sustainable practices, reduce our carbon footprint, and protect endangered species, ensuring that we learn from history rather than repeat it. By embracing these lessons, we can work towards a future that not only safeguards our planet, but also honors the legacy of those creatures that once ruled it. Dinosaurs have always captured our imagination, often leading to a swirling mix of fact and fiction surrounding these ancient creatures. One of the most pervasive misconceptions is the idea that all dinosaurs were gigantic, towering behemoths that roamed the earth. While many dinosaurs were indeed large, like the well-known Brachiosaurus and Tyrannosaurus rex, a significant number were much smaller. In fact, some were as tiny as a chicken. This diversity in size showcases the vast range of adaptations that dinosaurs developed over millions of years. Another common myth concerns the depiction of dinosaurs in popular culture, especially in movies and television shows. For instance, many portray these creatures as scaly beasts, much like modern reptiles. However, fossil evidence suggests that many dinosaurs, particularly theropods like Velociraptor, had feathers. This exciting revelation has reshaped our understanding of their appearance and behavior, suggesting that some of them may have been more closely related to birds than we ever thought. People often assume that dinosaurs are entirely extinct, but that's not entirely accurate. Birds are considered a direct descendant of theropod dinosaurs, meaning that in many ways dinosaurs are still alive today. This connection highlights the idea that extinction isn't always a clear-cut end. Instead, it can represent an extraordinary transformation over time in the evolutionary tree of life. The rise of avian life offers a living glimpse into the past. Lastly, the notion that dinosaurs walked in a cold-blooded, sluggish manner is not supported by recent research. Instead, paleontologists have found evidence suggesting many dinosaurs were likely warm-blooded, which would have given them the energy to thrive in diverse environments. This nuance in physiology indicates a more complex and dynamic ecosystem than the traditionally static image of these ancient reptiles, further emphasizing the remarkable adaptability that helped them dominate the planet for millions of years. Since their discovery, dinosaurs have captured the imagination of people across the globe, but it is in modern media that their mythology has truly flourished. Films, television shows, and literature have painted dinosaurs as fantastical creatures, larger than life, often exaggerating their size, behavior, and interactions with other species. Take, for example, the iconic film franchise Jurassic Park. It popularized the image of dinosaurs as ferocious predators, invoking a sense of danger that appealed to audiences' sense of adventure. Yet this portrayal oversimplifies the complexity of these creatures and their environments. One of the most significant impacts of media portrayals is the anthropomorphism of dinosaurs. In animated films and children's books, we often see dinosaurs depicted with human-like emotions, social structures, and dialogues. This not only entertains, but also fosters a misconception that these ancient beings lived and interacted similarly to humans. The appearance of friendly or relatable dinosaurs has fueled a wholesome mythos surrounding them, suggesting they had personalities and lived in harmonious ecosystems, which our understanding of paleontology does not entirely support. Moreover, sensational headlines and striking visuals can distort the reality of paleontological discoveries. When a new dinosaur species is uncovered, it garners media attention, often based on the most thrilling interpretations of the evidence, which can lead to misconceptions about these ancient animals. For instance, stories may focus on the ferocity of carnivores or the size of herbivores without providing the nuanced understanding of their behaviors, habitats, and interspecies relationships. The drive for engagement can overshadow factual representation, making the myth more captivating than the reality. Ultimately, these media portrayals create a captivating yet skewed image of dinosaurs that resonates deeply with audiences. While they inspire curiosity and a love for science, They simultaneously contribute to a myth-making process that can complicate our understanding of these fascinating creatures. As we tread the line between entertainment and education, it is important to embrace the wonder of dinosaurs while also grounding ourselves in the scientific truths that shape our knowledge of Earth's ancient past. Despite extensive research over the years, many unanswered questions about dinosaurs still linger in the minds of scientists. One of the most intriguing mysteries is how these magnificent creatures behaved in their natural environment. Did they exhibit complex social behaviors similar to modern-day birds, or were they more solitary in nature? Understanding their social dynamics could shed light on how they interacted with one another, nurtured their young, and organized themselves within their populations. Another captivating area of inquiry revolves around the specifics of dinosaur physiology, particularly their growth and development. Scientists are still piecing together how quickly dinosaurs grew and their metabolic rates. Did they grow as swiftly as modern mammals, or at a slower pace like reptiles? Insights into these factors may also reveal how they adapted to their environments, as well as whether they employed strategies for survival during different stages of their life cycles. The question of their coloration and physical appearance also remains tantalizingly unresolved. While it is widely accepted that some species likely displayed bright colors or patterns for mating or camouflage, the exact colorations of many dinosaurs remain a mystery. Recent discoveries of feathered dinosaurs hint at a vibrant world that we have yet to fully visualize, suggesting that their appearances could have been more similar to modern birds than we once imagined. Lastly, scientists grapple with understanding the extinction event that marked the end of the dinosaurs' reign millions of years ago. While the widely accepted theory includes a massive asteroid impact, the intricacies of how this event triggered widespread extinction are still being debated. Researchers continue to explore questions about what the world was like immediately before and after this catastrophic event, how it affected various species differently, and what factors contributed to the survival of certain creatures while others mysteriously vanished. These vestiges of the past invite us to keep questioning and exploring the depths of our planetary history. In recent years, discoveries about dinosaurs have overturned many long-standing beliefs and shed new light on these incredible creatures that roamed our planet millions of years ago. For decades, we pictured dinosaurs primarily as slow-moving, cold-blooded reptiles. However, advances in paleontology and comparative anatomy have led scientists to reevaluate their physiology, suggesting that many dinosaurs were warm-blooded and more active than we once imagined. One of the most fascinating revelations has been the evidence of feathers in various dinosaur species. Initially, feathers were thought to be exclusive to birds, but over the past couple of decades, fossils discovered in China have unveiled feathered dinosaurs, challenging the traditional image of scaly, lizard-like creatures. This has significant implications for our understanding of the evolutionary connection between dinosaurs and birds, illustrating that some theropod dinosaurs like Velociraptor were more similar to modern birds than to modern reptiles. Furthermore, recent studies have revealed intricate social behaviors among dinosaurs. Fossils found in specific formations show signs of herding and even nesting behaviors, suggesting that some species may have exhibited complex social structures and parental care. This level of social interaction was not part of the classic, solitary image of dinosaurs and indicates that they may have had more in common with today's social mammals than previously thought. These discoveries highlight how paleontology continues to evolve, urging us to reconsider what we think we know about dinosaurs. As new fossils are unearthed and advanced technologies such as imaging techniques and computer modeling are applied, our understanding of these magnificent creatures becomes increasingly nuanced and exciting. Ultimately, each new discovery not only reveals the truth about dinosaurs, but also deepens our appreciation for the fascinating story of life on Earth. Fossilized footprints serve as remarkable time capsules, offering glimpses into the lives of dinosaurs long gone. When a dinosaur walked across soft ground, it left a trace that captures not only the size and shape of the creature's feet, but also hints at its behavior, social interactions, and habitat. By studying these footprints, paleontologists gather insights that go beyond mere size estimates. One of the most intriguing aspects of footprints is the information they provide about the movement of dinosaurs. The depth and spacing of the prints can indicate whether a dinosaur was walking, running, or even trotting. For instance, closely spaced footprints may suggest a fast pace, possibly reflecting a moment of urgency, while widely spaced tracks could point to a more leisurely stroll. Observing these patterns helps scientists determine not just how fast a dinosaur could move, but also how it hunted or escaped potential predators. Additionally, tracks can reveal social behavior. Fossilized footprints often show multiple individuals walking together, suggesting that some dinosaurs traveled in packs or herds. The variety of track sizes found in a single location can indicate different species cohabiting or perhaps even a family structure within a species. This kind of evidence supports theories about social dynamics and parenting behaviors among dinosaurs, which were once thought to be solitary creatures. Overall, the study of dinosaur footprints paints a richer picture of their daily lives and environments. Each set of tracks serves as a narrative thread in the larger tapestry of Earth's prehistoric past, guiding researchers as they reconstruct the habits and habitats of these fascinating creatures. As more sites are discovered and investigated, our understanding of dinosaur behavior continues to deepen, reminding us of the complexity and diversity of life that once roamed our planet. The story of dinosaurs begins long before they roamed the Earth in their majestic forms. Their earliest ancestors can be traced back to small reptilian creatures known as archosaurs, which lived during the Triassic period over 200 million years ago. Some of these early archosaurs looked somewhat like crocodiles and were quick on their feet, adapting to diverse habitats. These ancestors had certain key features that would set the stage for the evolution of dinosaurs, such as upright limb posture and specialized teeth for varying diets. As the Triassic period progressed, a combination of environmental changes and evolutionary pressures led to the emergence of true dinosaurs. This remarkable transition involved adaptative radiation, where a single lineage diversified into a wide array of species. Among the first true dinosaurs were the bipedal theropods, similar to the modern-day chicken, and the more massive sauropodomorphs, which would evolve into giants like Brachiosaurus and Diplodocus. Their adaptations for different environments and dietary needs played crucial roles in this evolutionary process. During the Jurassic period, the dinosaurs truly began to dominate the land. This was a time of lush vegetation and vast ecosystems, providing ample opportunities for diversification. Some dinosaurs developed elongated necks and powerful tails to help them reach high into trees for food, while others became formidable predators, equipped with keen senses and sharp teeth. The competition among various dinosaur species led to innovations in size, speed, and survival strategies, paving the way for the massive varieties we recognize today. As the Cretaceous period dawned, dinosaurs had established themselves as the dominant terrestrial vertebrates. The sheer diversity of forms and ecological roles they filled is astonishing. From the theropods that evolved into the formidable Tyrannosaurus rex to the colossal long-necked sauropods, the evolutionary journey of these creatures showcases nature's incredible ability to adapt and innovate. The extinction event that occurred at the end of the Cretaceous did not end their story, however, as it led to the rise of birds, the descendants of small theropods, demonstrating that the legacy of dinosaurs continues to fly overhead even today. The Mesozoic era, often referred to as the Age of Reptiles, spanned approximately 180 million years, during which dinosaurs emerged and flourished. Dinosaurs evolved through a unique combination of anatomical innovations, adaptive strategies, and ecological niches, distinguishing them from other reptiles of the time. While both dinosaurs and their reptilian relatives shared common ancestry, the transformations they underwent branched out in fascinating and divergent ways. Dinosaurs developed characteristics that set them apart from other reptiles. For instance, they possessed an upright posture which enabled them to support massive bodies with a more efficient skeletal structure. This adaptation allowed for greater mobility and agility. In contrast, many other reptiles of the era, such as crocodiles and lizards, maintained a sprawling gait. Dinosaurs also showcased a remarkable range of sizes and forms, from the towering, long-necked sauropods to the agile, feathered theropods, adapting to different environments and dietary needs. While dinosaurs ruled the land, other reptiles took to the skies and oceans. Flying reptiles, known as pterosaurs, evolved alongside dinosaurs, developing wings and a lightweight structure that allowed them to glide through the air. Aquatic reptiles such as ichthyosaurs and plesiosaurs adapted to life in the oceans, growing streamlined bodies and powerful limbs for swimming. These various reptiles coexisted, each exploiting different habitats and resources, showcasing the rich diversity of life during the Mesozoic era. Ultimately, the evolutionary pathways of dinosaurs and other reptiles illustrate the dynamic nature of life on Earth. While dinosaurs became the dominant terrestrial animals, the adaptations of other reptiles reveal how these creatures too carved out their niches in a world of change and upheaval. This era set the stage for the intricate web of life we continue to explore today, highlighting the themes of adaptation and survival that resonate through the history of our planet. Dinosaurs, those remarkable giants of the past, possessed several genetic traits that set them apart from other reptiles. One of the most notable features is their posture. Dinosaurs had an upright stance, with legs positioned directly beneath their bodies. This skeletal structure allowed for more efficient movement and support compared to most contemporary reptiles, which often have sprawling limbs. This unique leg positioning not only provided them with agility, but also gave rise to varied locomotion strategies. Another distinct genetic trait of dinosaurs is their mode of reproduction. They were oviparous, like other reptiles, laying eggs. However, the nesting behaviors and parental care observed in some dinosaur species suggest a complex evolutionary strategy. Fossil evidence shows that certain dinosaurs might have cared for their young in ways we do not see in most modern reptiles, which often abandon their eggs after laying them. This suggests a level of social and reproductive behavior that is quite advanced for reptiles. The skin of dinosaurs also differentiates them from present-day reptiles. Many dinosaur fossils point to a covering of feathers or protofeathers, especially in theropod dinosaurs, which are closely related to birds. This indicates an evolutionary connection between some dinosaurs and avian species, showcasing traits for insulation and possibly display. In contrast, most reptiles today have scales, which serve a different purpose and reflect a distinct evolutionary adaptation. Lastly, dinosaurs exhibited a growth pattern that was unique among reptiles. Many showed evidence of rapid growth rates, which is rare among their modern relatives. This adaptability likely helped them thrive in various environments during the Mesozoic era. By understanding these unique genetic traits, we gain insights into not just the biology of dinosaurs, but also their evolutionary significance in the larger tapestry of life on Earth. The study of dinosaur evolution serves as a fascinating window into the mechanisms of adaptation that shape life on Earth. Dinosaurs, having roamed our planet for over 150 million years, showcase a remarkable variety of adaptations that allowed them to thrive in diverse environments. By examining their evolutionary paths, scientists can unravel the intricate processes that drive change in species through time, shedding light on both ancient and contemporary life. For instance, consider the way certain dinosaurs developed specialized teeth for different diets, such as the long-necked sauropods, which evolved to feed on treetops, and the fierce theropods, whose sharp teeth served predation. These adaptations illustrate not just survival tactics, but also the broader principles of natural selection, where traits beneficial for survival in a particular environment become more prevalent in successive generations. Understanding these dynamics helps scientists recognize similar patterns in modern species, offering insights into how current animals adapt to changing environments. Additionally, the fossil record provides a rich tapestry of how dinosaurs responded to climatic shifts over millions of years. When environmental conditions fluctuated, those species that could adapt quickly often thrived, while others faced extinction. This evolutionary trial and error offers crucial clues to contemporary biodiversity, especially as many species today confront rapid climate change and habitat destruction. It serves as a reminder of the resilience found in life forms and their capacity to evolve. Ultimately, the stories told through dinosaur evolution extend beyond the prehistoric past. They resonate with the ongoing narrative of life on Earth. By studying the adaptations that allowed dinosaurs to dominate for so long, we gain invaluable knowledge that may help us understand how current and future species might react in an ever-changing world. This connection enriches our perspective not only about the ancient giants that once walked the earth, but also about the interconnected web of life we continue to share today. The discovery of soft tissue in dinosaur fossils is nothing short of groundbreaking. For many years, scientists believed that the organic materials in dinosaur remains could not survive the passage of millions of years. However, the finding of preserved soft tissues, such as blood vessels and even cells in some instances, has challenged this long-standing view and opened up exciting avenues for research. The implications of these discoveries are profound. Firstly, they offer a glimpse into the biology of dinosaurs, allowing scientists to study their cellular structure and possibly their genetics. This could lead to a better understanding of how these ancient creatures lived, how they grew, and how they adapted to their environments. For instance, analyzing soft tissue can help unravel details about their diets, health, and even their evolutionary relationships with modern birds and reptiles. Moreover, finding soft tissue has implications for the field of paleontology as a whole. It raises questions about the conditions under which these tissues can be preserved for such extended periods. Understanding this could refine our methods for extracting and interpreting fossil evidence, potentially leading to groundbreaking discoveries of other types of organisms preserved in similar ways. Lastly, this research stirs the imaginations of scientists and enthusiasts alike, fostering a narrative of connectivity between the past and present. It reawakens the fascination with extinct species and how they once roamed our planet, and it inspires future generations to dig deeper into our planet's history, revealing tales that span millions of years. Soft tissue in dinosaur fossils signifies a remarkable intersection of discovery and wonder, reminding us that the story of life on Earth is far from complete. Paleontology, the study of ancient life, employs several core methods to analyze the remains of dinosaurs. One of the primary techniques is excavation, where paleontologists carefully unearth fossils from sedimentary rock. This process requires a delicate touch to avoid damaging the bones, as many fossils may be fragile or partially eroded. Once a fossil is uncovered, it is meticulously cleaned and documented, providing essential information about the specimen's context within the rock layer. Another fundamental method involves comparative anatomy. Paleontologists analyze the physical characteristics of dinosaur bones, comparing them to both modern-day animals and other fossilized remains. This comparison helps researchers identify species, understand evolutionary changes, and discover relationships between different dinosaur groups. Practicing this technique reveals fascinating insights into how dinosaurs adapted to their environment, from their body shapes to their feeding habits. Additionally, technology plays an increasingly crucial role in paleontology. Techniques such as computed tomography or CT scanning allow scientists to look inside fossils without breaking them apart. This non-destructive method offers a detailed view of the internal structures of bones, helping to uncover crucial information about growth patterns and health conditions of these ancient creatures. Furthermore, advanced imaging tools generate three-dimensional models, enabling researchers to recreate the posture and movement of dinosaurs more accurately than ever before. Lastly, paleontologists also utilize isotopic analysis, which studies the ratios of different stable isotopes within fossilized remains. This method can provide insights into the diets of dinosaurs and their living conditions. By examining the chemical signatures in the bones and teeth of these animals, scientists can learn about their habitat, climate, and even migratory patterns. Each of these methods contributes to a broader understanding of dinosaurs, shedding light on the rich tapestry of life that once roamed our planet. Fossilized remains are treasure troves of information, illuminating the physical abilities and limitations of dinosaurs over millions of years. When paleontologists study these ancient remnants, they examine not only bones but also footprints, teeth, and even coprolites, which are fossilized feces. Each piece carries clues about how these creatures moved, fed, and interacted with their environment. For instance, the size and shape of a dinosaur's limbs can indicate its speed or stamina, while the structure of its skull can reveal important details about its diet. Take, for example, the discovery of a dinosaur's footprints. These tracks can tell us much about its behavior, the spacing between prints can suggest how fast the dinosaur was moving. A trackway with consistent, deep impressions might imply a heavy, lumbering creature, while lighter, more delicate prints could belong to a faster, more agile one. This evidence helps scientists recreate the dinosaur's lifestyle, whether it was a swift predator or a lumbering herbivore. Fossils also provide insights into anatomical adaptations. The robustness of bones can indicate whether a dinosaur had strong muscles. For instance, the massive leg bones of the Tyrannosaurus rex suggest it was a powerful runner, while the lightweight, hollow bones of some theropods hint at their ability to take flight. Additionally, the wear patterns on teeth can indicate whether a dinosaur was primarily herbivorous, carnivorous, or omnivorous, thereby giving us a fuller picture of its ecological niche and evolutionary strategies. Ultimately, the study of fossilized remains is like piecing together a complex puzzle. Each fossil adds a unique piece, revealing the majestic diversity and adaptability of dinosaurs. By analyzing their physical traits, scientists can leadingly narrate the story of how these incredible beings lived, thrived, and ultimately became extinct, all within the vast tapestry of Earth's history. Isotopic analysis serves as a fascinating window into the diets of ancient dinosaurs, offering clues to their feeding habits and the ecosystems they inhabited. At its core, this method examines the ratios of different isotopes, or variations of elements, present in the fossilized remains of these creatures. By focusing predominantly on stable isotopes, such as carbon and oxygen, scientists can glean invaluable insights into the types of plants or prey that would have made up their diets. When it comes to carbon isotopes, the ratio of carbon-12 to carbon-13 tells us about the type of vegetation that dinosaurs consumed. For instance, plants known as C3 use carbon dioxide from the atmosphere during photosynthesis, leading to a distinct isotopic signature. These plants typically thrive in cooler, wetter environments and include many trees and shrubs. Conversely, C4 plants, which include grasses and some sedges, flourish in warmer and drier conditions. By analyzing these ratios in dinosaur bones or teeth, researchers can infer whether a particular species was grazing on lush vegetation or munching on grasslands. Oxygen isotopes play a complementary role in this analysis. The ratios of oxygen-18 to oxygen-16 can reveal information about the aquatic environments the dinosaurs inhabited. This aspect helps paleontologists understand not only where these creatures lived, but also the climate conditions during their time. An isotopic signature can indicate whether a dinosaur spent time in a moist ecosystem or a dry desert. Through isotopic analysis, scientists are piecing together a clearer picture of how different dinosaur species interacted with their environment and with each other. In doing so, we learn much about the diversity of their diets. While some, like the towering sauropods, were primarily herbivores, others may have had a more varied diet, blending meat and plants, all reflecting a rich tapestry of life long gone. This method truly underscores the intricate links between lifestyle, habitat, and survival in the age of dinosaurs. Advancements in imaging technology have revolutionized our understanding of dinosaur remains tremendously. A few decades ago, paleontologists relied heavily on traditional excavation and the physical study of fossilized bones. Today, innovative imaging techniques like computed tomography and high-resolution X-ray imaging allow scientists to explore the internal structures of fossils without causing damage. This non-invasive approach means that researchers can visualize what lies within the dense rock surrounding a fossil, revealing intricate details previously hidden from sight. For instance, using these advanced imaging tools, scientists have discovered soft tissues within dinosaur bones that were once assumed to be long gone. These soft tissues consist of blood vessels and even potential proteins, generating excitement about what they can tell us regarding the biology and behavior of these ancient creatures. The insight gained from these discoveries is transforming our understanding of dinosaur physiology and how they may have lived millions of years ago. Furthermore, imaging technology has played a vital role in the analysis of dinosaur eggs and nests. By using three-dimensional imaging, researchers can study the details of the eggshell structure and the arrangement of nests, providing evidence about the reproductive behaviors of dinosaurs. These findings help us build a richer picture of their life cycles and parental care, illustrating that dinosaurs were far more complex than once imagined. Overall, the integration of sophisticated imaging techniques into paleontology offers a window into the distant past. It allows us to uncover fine details that shift our perspectives on how dinosaurs lived, reproduced, and evolved. This technological evolution is exciting, as it continually reshapes our understanding of these majestic creatures and further ignites our curiosity about life on Earth millions of years ago. Aspiring paleontologists embark on a fascinating journey through time, studying the history of life on Earth preserved in rocks and fossils. To thrive in this captivating field, they need a solid foundation in the natural sciences. A bachelor's degree in paleontology, geology, biology, or a related discipline is essential. This educational background provides the critical knowledge of evolutionary biology, the formation of Earth, and the various life forms that have existed. But education alone isn't enough. Aspiring paleontologists should develop strong practical skills through hands-on experiences. Fieldwork is a significant aspect of paleontology, requiring proficiency in excavation techniques and an understanding of geological formations. Being skilled in identifying fossils and accurately documenting their locations is vital. Techniques in preparing specimens for study, involving meticulous cleaning and preservation, are also crucial. In addition, familiarity with relevant tools such as brushes, picks, and chisels can enhance their field skills. Communication skills are equally important. Paleontologists often work as part of a team, collaborating with other scientists and sharing their findings with the public and academic communities. Strong writing abilities enable them to publish research papers, while effective verbal communication helps them present their work at conferences and in educational settings. Teaching others about the intricacies of ancient life can inspire future generations and garner interest in the field. Finally, developing a keen analytical mind is essential. Gauging how to interpret the fossil record, understanding the implications of their findings, and asking the right questions drive discovery in paleontology. Aspiring paleontologists are encouraged to embrace curiosity and foster a passion for lifelong learning as new discoveries are made and technologies evolve. By honing these essential skills and embracing their love for ancient life, they can truly make their mark in this riveting scientific field. Modern reptiles and birds are fascinating windows into the behaviors of their ancient ancestors, the dinosaurs. Birds, in particular, exhibit numerous traits that not only link them back to the age of dinosaurs, but also showcase the evolutionary adaptations that have taken shape over millions of years. For example, many birds engage in complex social behaviors, including intricate mating displays and flock formations, reminiscent of those seen in some dinosaur species. Among reptiles, certain behaviors stand out. Crocodiles, for instance, display nurturing behaviors, such as creating nests for their eggs and protecting their young. These parenting methods are akin to those believed to have been practiced by some theropod dinosaurs, suggesting continuity in behavior that stretches back through the ages. Observing these living reptiles gives us a glimpse into strategies for survival that have persisted from the time of the dinosaurs to the present day. In the realm of locomotion, there are also striking comparisons. Modern birds exhibit various modes of flight, with some even capable of gliding, which echoes the agility of small theropods that roamed the earth. The way certain reptiles, like iguanas, navigate their environments by climbing and swimming shows parallels to how some dinosaurs may have utilized diverse habitats during their reign. These activities speak to the adaptability of these species, enduring strategies passed down through generations. Furthermore, ongoing research continues to uncover more surprising links. For example, studies of feathered dinosaurs reveal similar plumage arrangements and coloration patterns seen in some modern birds. The social interactions seen in dinosaur fossils hint at possible complex behaviors involving communication and social hierarchy, much like those observed in current avian species. Every discovery illuminates the remarkable continuity that exists within the animal kingdom, reminding us that today's reptiles and birds are not just descendants of the dinosaurs, but active participants in a living history stretching back through time. When we think of dinosaurs, we often envision gigantic lizards roaming the earth millions of years ago. However, one of the most intriguing revelations from paleontology is that today's birds are the direct descendants of certain theropod dinosaurs. This evolutionary connection is evident in numerous anatomical similarities that link these two groups. To start, one of the most notable similarities is the structure of the skeleton. Both birds and theropod dinosaurs share hollow bones, which help to reduce weight without sacrificing strength. This adaptation is critical for flight, allowing modern birds to soar gracefully through the skies. Additionally, the forelimbs of theropod dinosaurs evolved into the wings of birds, showcasing a remarkable transformation that enabled the mastery of flight. Another remarkable similarity lies in the arrangement of their hips. The pelvic structure of birds is quite similar to that of some dinosaurs. In both groups, the bones are designed in a way that supports bipedal locomotion. This commonality reflects their shared evolutionary history and highlights the functional adaptations necessary for an active lifestyle on land, whether chasing prey or fleeing from predators. Lastly, feathers, which are a hallmark of birds, also have origins in some theropod dinosaurs. Fossils have revealed that many species had feather-like structures, providing insulation and possibly aiding in display behaviors. This innovative development eventually led to the evolution of true feathers, giving rise to the diverse and colorful plumage we see in birds today. Overall, the anatomical similarities between dinosaurs and birds not only showcase their shared ancestry, but also provide a glimpse into the extraordinary evolution of life on our planet. Studying modern ecosystems provides vital clues about how ancient environments functioned, especially during the age of dinosaurs. By observing current ecosystems, scientists can draw parallels and make educated guesses about how similar processes might have operated millions of years ago. For instance, the relationships between plants and animals today can help reconstruct the dietary habits and habitats of prehistoric creatures. Take, for example, the many ways we observe animals interacting with their environment. In today's ecosystems, we see herbivores shaping the landscape by grazing on vegetation. This behavior affects not just the plants that are consumed, but also the entire ecosystem surrounding them. By comparing these interactions with fossil evidence from the time of dinosaurs, researchers can infer how dinosaurs may have influenced their habitats in similar ways, sculpting ecosystems through their feeding habits and migrations. Moreover, modern environmental conditions such as climate patterns, soil composition, and floral diversity serve as a foundation for inferring those that existed in the past. Studying regions where fossils are found, scientists can analyze the types of plants that might have thrived in those climates and how they could have provided sustenance for dinosaurs. For example, the presence of certain fossilized pollen can unveil not just what dinosaurs ate, but the climate they lived in, shedding light on temperature ranges and precipitation patterns. Ultimately, these insights from modern ecosystems are indispensable in piecing together the puzzle of our planet's history. By blending contemporary observations with ancient evidence, scientists create a robust understanding of how life on Earth has evolved and adapted, leading to vivid reconstructions of the vibrant worlds where dinosaurs roamed. The synergy between the past and present enhances our appreciation not only for the life forms that existed long ago, but also for the intricate systems that govern life today. Dinosaurs, the magnificent creatures that roamed our planet millions of years ago, displayed a range of survival strategies that can still be observed in modern animals today. For instance, some dinosaurs are believed to have had social behaviors similar to those of today's herd animals, like elephants or wildebeests. These animals work together to provide safety in numbers, a concept that may have applied to large herbivorous dinosaurs as they moved in groups to evade predators. One of the most fascinating aspects of dinosaur behavior was their nesting strategies. For example, certain species likely built nests and took care of their young, much like modern birds and reptiles do. We find evidence of this in numerous fossilized nests discovered around the world, showcasing that parenting behaviors were not new even back then. Today, many animals exhibit similar nurturing behaviors, ensuring that their offspring survive in a challenging world, which often includes protecting them from potential threats. Furthermore, many types of dinosaurs developed methods of communication, whether through vocalizations, body language, or display. This echoes in the animal kingdom today, where creatures communicate to express dominance, attract mates, or warn others of danger. The vibrant calls of frogs or the intricate dance of bees serve as reminders that the need for communication as a survival mechanism is a trait passed down through the ages, deeply embedded in the fabric of life on Earth. Finally, consider the camouflage and mimicry strategies demonstrated by dinosaurs. While some may have relied on their sheer size, many small dinosaurs could exhibit colors and patterns to blend in with their surroundings. This is remarkably similar to modern-day chameleons or certain insects that use color and texture to avoid predators. The survival tactics of adaptation and disguise are as relevant today as they were during the age of dinosaurs, proving that while the species have changed, the fundamental strategies for survival remain timeless. Throughout Earth's history, there have been 5 major mass extinction events, marked by dramatic and rapid declines in biodiversity. Each of these events reshaped the planet's ecosystems, often due to catastrophic causes like volcanic eruptions, asteroid impacts, or dramatic climate shifts. The most famous of these was the extinction of the dinosaurs, occurring around 66 million years ago when a giant asteroid struck the Earth, leading to widespread environmental chaos. In these cases, life on Earth took millions of years to recover, reshaping the biosphere into new forms. Modern-day challenges for wildlife, while not occurring at the same catastrophic scale, nonetheless pose significant threats to biodiversity. Human activities, such as habitat destruction, pollution, climate change, and overexploitation of resources, have accelerated the loss of species at an alarming rate. It's estimated that current extinction rates are much higher than the background rate which existed before human influence, leading some scientists to describe this period as the 6th mass extinction. Animals such as the saola, a rare forest-dwelling ox found in Vietnam, represent just one example of species teetering on the brink due to habitat loss and poaching. Interestingly, while past extinction events were largely driven by natural disasters, the current crisis involves human choices and activities. Climate change, driven by fossil fuel consumption, is altering habitats and climatic conditions at a pace that many species cannot adapt to. The increased frequency of extreme weather events, ocean acidification, and rising sea levels are all changing the delicate balances that allow ecosystems to thrive, suggesting that we need to reconsider our relationship with nature and its limits. Despite these challenges, there is hope. Conservation efforts worldwide are working to protect endangered species and restore habitats. Technology and science are being harnessed to monitor wildlife populations and mitigate threats. By learning from past extinction events, humanity has an opportunity to forge a path towards sustainability, ensuring that the rich tapestry of life on Earth can endure for future generations. Recently, several new technologies are emerging that have the potential to revolutionize how we study dinosaurs, enhancing our understanding of these magnificent creatures. One of the most exciting advancements is the use of 3-dimensional imaging techniques, like computed tomography. This method allows scientists to create detailed digital models of dinosaur bones and fossils without damaging the specimens. Researchers can then examine internal structures and better understand the biology and growth patterns of these ancient animals. Another significant technological progress is in the area of geochemistry. Techniques such as stable isotope analysis enable scientists to investigate the diet, climate, and migration patterns of dinosaurs by examining the chemical signatures preserved in their bones and teeth. This innovative approach can provide insights into the environmental conditions that influence their evolution and extinction, offering a clearer picture of life during the Mesozoic era. Moreover, artificial intelligence is emerging as a valuable tool for paleontologists. By analyzing vast datasets of fossil records, machine learning algorithms can identify patterns and relationships that might remain hidden to the human eye. These technologies can help locate new fossil sites or predict the presence of certain dinosaur species based on environmental variables. Finally, advancements in remote sensing and imaging are allowing researchers to explore sites previously inaccessible, such as deep-seated layers in sedimentary rock formations. Drones and satellite imagery can now assist in identifying fossil-rich deposits, making the process of discovering new dinosaur remains more efficient and opening the door to previously unexamined territories. With these exciting technologies, we are poised to unlock even more secrets of the dinosaurs that once roamed our planet. Collaborative international research plays a pivotal role in enhancing our understanding of dinosaurs on a global scale. Dinosaurs roamed across various continents, each region offering unique fossil finds that hold clues to the diversity and evolution of these magnificent creatures. When scientists from different countries work together, they bring their unique expertise, access to local fossils, and varying methodologies to the table. This shared knowledge leads to a richer and more nuanced picture of dinosaur life. One of the remarkable aspects of such collaborations is the pooling of resources. Funding, equipment, and technology can be quite limited in certain regions, but by collaborating internationally, scientists gain access to a broader range of tools and databases. This means that techniques such as advanced imaging and genetic analysis can be applied more widely, allowing for more detailed studies of existing fossils and the possibility of discovering new species. By combining efforts, researchers can also conduct comprehensive studies that track the migrations and habitats of dinosaurs, painting a clearer picture of how these animals interacted with their environments. Moreover, international partnerships foster the exchange of ideas and innovation. Scientists from different cultural backgrounds approach problems and questions about dinosaurs in unique ways. This exchange can spur creative solutions and unexpected findings. For instance, a researcher might apply a technique used in paleobotany to analyze dinosaur bone structure, uncovering new insights about how they lived and thrived in their respective ecosystems. Lastly, collaborative research contributes to education and outreach, impacting public understanding of dinosaurs on a global scale. By sharing discoveries through joint publications, seminars, and museums, a wider audience can appreciate the significance of paleontological research. This not only ignites interest in science among young students, but also cultivates a global appreciation for the history of these remarkable animals that once dominated our planet. Collaborative international research not only deepens our understanding of dinosaurs, but also connects us to our planet's ancient past in ways that transcend borders. In the fascinating world of paleontology, scientists are continuously unraveling the mysteries of our planet's distant past, particularly the age of dinosaurs. As research progresses, experts are eager to make discoveries that will enhance our understanding of dinosaur behavior, evolution, and their eventual extinction. One significant area of interest is the investigation of dinosaur nesting sites and fossilized eggs. By examining these finds, scientists hope to uncover insights into their reproductive habits and parenting behaviors. Were they nurturing mothers or more aloof? Each new discovery sheds light on these ancient creatures' complex lives and social structures. Another area ripe for exploration is the molecular analysis of dinosaur bones. The discovery of preserved soft tissues, proteins, and even the potential for recovering ancient DNA offers an exciting frontier. Understanding the biochemical makeup of dinosaurs could not only reveal how they lived, but also how they adapted to their environments. This leads to questions about their physiology and metabolism, which could be quite different from the common image we have of them as large, lumbering beasts. Imagine uncovering how some dinosaurs might have had feathers or even unique colors, which would challenge long-held assumptions about their appearance and behavior. Additionally, climate change and its impact on the planet's ecosystems is a growing concern. By studying the fossil record, scientists aim to understand how dinosaurs adapted to different climate regimes. This might help develop models that explain how species have responded to past global changes, possibly providing lessons for today's biodiversity challenges. Understanding how dinosaurs coped with shifts in climate gives us a broader perspective on resilience and adaptability in the face of environmental stresses. Finally, the use of advanced technology, including artificial intelligence and high-resolution imaging, promises to revolutionize paleontological research. These tools can analyze large datasets, helping to identify previously unrecognized patterns in dinosaur morphology and behavior. As scientists piece together the complex puzzle of dinosaur history, the future of paleontology holds the potential for exciting discoveries, ensuring that our understanding of these incredible creatures continues to evolve. As we move forward into the coming decades, public interest in dinosaur research is poised to evolve significantly, influenced by several dynamic factors. Firstly, advancements in technology are reshaping how we discover and study these ancient creatures. New methods, like computer simulations and artificial intelligence, allow scientists to analyze fossils and reconstruct behaviors in ways that were unimaginable just a few years ago. This fresh approach can spark greater public curiosity and understanding as people see vivid portrayals of dinosaurs in action rather than mere skeletons in glass cases. Additionally, the role of media in promoting science is invaluable. Film and television continue to mesmerize audiences with depictions of dinosaurs that blend factual research with enthralling storytelling. As platforms for documentaries, streaming services, and social media evolve, they provide fertile ground for engaging educational content about dinosaurs. This easy access to information can capture the imaginations of younger generations, inspiring a desire to dig deeper into our planet's prehistoric past. Moreover, there's a growing emphasis on interdisciplinary approaches within scientific research. Paleontology is increasingly intersecting with fields such as ecology, climate science, and genetics. This cross-pollination of ideas not only enriches our understanding of dinosaurs, but also underscores their relevance to contemporary issues. For instance, exploring how these enormous creatures adapted to changing environments can offer valuable lessons about our own time, igniting a broader public discourse about extinction and conservation. Lastly, the surge in dinosaur-themed activities, such as museum exhibitions and educational programs, is likely to thrive as communities seek engaging ways to connect with science. Interactive experiences like fossil digs and virtual reality explorations of prehistoric worlds make learning about dinosaurs more accessible and enjoyable. By fostering a sense of wonder and discovery, interest in dinosaur research is set to thrive, paving the way for an enduring fascination with these magnificent beings that once roamed our Earth. Educational initiatives play a crucial role in bridging the gap between scientific research and public understanding. One effective approach is to create engaging and accessible content that highlights ongoing research and exciting discoveries in cosmology. Utilizing various media platforms such as documentaries, podcasts, and social media can significantly enhance the reach and impact of these initiatives. For instance, short videos featuring scientists explaining their work can capture attention while making complex topics more relatable. Another important aspect is promoting community involvement in scientific discourse. Organizing public lectures, workshops, and open labs can foster interactive learning experiences. These informal settings create opportunities for individuals to ask questions and engage directly with researchers. By building relationships between scientists and the community, trust and enthusiasm for science can blossom, leading to a more informed public willing to embrace new knowledge. Collaborating with schools and educational institutions is also vital. Integrating recent scientific findings into school curricula ensures that the next generation develops an understanding of current research. Teacher training programs focused on incorporating real-time discoveries into lessons can inspire young minds to appreciate science. Educational resources should be designed to be both informative and enjoyable, helping to spark curiosity and nurture a lifelong passion for learning about the universe. Finally, using storytelling to frame scientific discoveries can make the information more compelling. When researchers share the narrative behind their work, their motivations, the challenges faced, and the broader implications for humanity, audiences are more likely to connect with the subject matter. By emphasizing the human element of scientific exploration, educational initiatives can create a shared sense of wonder and encourage public dialogue about the astonishing revelations waiting to be uncovered in the cosmos. During their reign on Earth, dinosaurs occupied a multitude of ecological roles, fundamentally shaping the ecosystems around them. As both predators and prey, they established intricate food webs that supported a diverse array of life. The large herbivorous dinosaurs, like the long-necked sauropods, played a crucial role in plant life. Their feeding habits influenced vegetation patterns as they consumed massive amounts of foliage, ultimately shaping the landscapes of their time. This interaction encouraged the evolution and adaptation of various plant species as they had to evolve defenses against these gigantic eaters. Carnivorous dinosaurs, on the other hand, maintained the balance within these ecosystems. Fierce predators, such as the Tyrannosaurus rex and the Velociraptor, hunted herbivores, helping to regulate their populations. This dynamic ensured that no single species would dominate the ecosystem, allowing a variety of other organisms, including smaller mammals and birds, to thrive alongside dinosaurs. The predatory tactics also led to the evolution of faster and more agile prey, driving an evolutionary arms race that fostered diversity. Dinosaurs also played a significant role in nutrient cycling. Their waste products returned essential nutrients back to the soil, enriching the environments in which they lived. This natural fertilization benefited plant life, promoting growth and enabling other species to flourish, thereby increasing biodiversity. Even their death had an ecological impact, as the decomposition of their massive bodies provided nourishment for scavengers and decomposers, further supporting the ecosystem. The presence of dinosaurs also influenced the evolution of other species. The adaptation strategies of various animals, including mammals and birds, were shaped by their interactions with dinosaurs, leading to the development of new survival strategies. In a broader ecological sense, the legacy of dinosaurs continues to impact our planet today, as their once thriving ecosystems are echoed in the complex relationships seen in modern environments. Thus, dinosaurs were not simply rulers of the land, they were vital architects of the ecological tapestry that flourished during the Mesozoic era. Dinosaurs dominated the Earth for over 150 million years, which profoundly shaped the evolutionary landscape in several ways, particularly for mammals. During this time, mammals were relatively small and mostly nocturnal creatures, living in the shadows of these incredible reptiles. While dinosaurs thrived, they created a world that required mammals to adapt in unique ways to survive. This period of coexistence pushed mammals to develop traits that would be crucial for their survival. When the dinosaurs went extinct about 65 million years ago, primarily due to a catastrophic event, a significant opportunity arose for mammals. With the dinosaurs no longer filling the large ecological niches, mammals began to diversify dramatically. As they expanded into these new environments, they adapted and evolved into different forms. This explosion of mammalian diversity gave rise to the vast array of species we see today, including humans. Moreover, the extinction of dinosaurs allowed mammals to grow larger and more varied in size and form. They evolved into various niches, ranging from tiny shrew-like creatures to enormous elephants. This adaptability led to the rise of important groups such as primates, which eventually gave rise to the lineage that would lead to humans. The resource-rich environments available in the aftermath of the dinosaurs played a crucial role in this evolutionary leap. One fascinating point is that the mammal-dinosaur dynamic was not merely one of competition, but also a complex web of interactions. While dinosaurs ruled the land, many smaller mammals developed traits such as enhanced sensory abilities and social structures that would later facilitate their eventual dominance. The extinction of dinosaurs, therefore, was not just an end, but a remarkable beginning for mammals, leading to an era where they could finally thrive and evolve in ways previously unimaginable. Dinosaur fossils play a crucial role in helping us understand Earth's geological history. They serve as windows into a time that spanned over 160 million years, allowing scientists to piece together how the planet has changed over eons. These fossils are not just remnants of ancient creatures. They provide invaluable information about past climates, ecosystems, and the dynamic processes that have shaped our world. As paleontologists study these fossils, they uncover clues about the environments in which dinosaurs lived. For example, fossils found in what is now North America suggest that during the late Cretaceous period, there were lush forests, marshes, and rivers. This contrasts sharply with the arid deserts we see in many of those same locations today. By examining the types of dinosaur species that existed in various regions, scientists can infer how climatic conditions fluctuated over millions of years. Moreover, dinosaur fossils help us understand mass extinction events and their impacts on life on Earth. The most famous extinction event occurred about 66 million years ago when a cataclysmic event, perhaps an asteroid impact, led to the rapid demise of dinosaurs. Studying how these creatures lived and eventually went extinct informs us about the resilience of life and the intricate relationships within ecosystems, emphasizing how both biological and geological forces interact. The significance of dinosaur fossils extends beyond mere curiosity. They are essential to reconstructing the narrative of our planet's history, illuminating past climates and ecosystems, revealing the consequences of catastrophic events, and deepening our appreciation for the ever-evolving tapestry of life on Earth. Each discovery adds a piece to the puzzle of our planet's vast geological story, igniting wonder about the forces that have shaped and continue to shape our world. The reign of dinosaurs, which spanned millions of years, significantly influenced the biodiversity of the Earth's landscapes. These colossal creatures roamed various habitats, from lush forests to arid deserts, shaping not just their environment but the very course of evolution itself. Their very presence created pathways for other organisms, transforming ecosystems in ways that still echo today. Dinosaurs were not solitary beings. Their interactions with plants and smaller animals played a crucial role in the ecological tapestry. For instance, many dinosaurs were herbivores, and their massive grazing habits impacted plant communities, promoting the growth of certain types of vegetation while suppressing others. This selective feeding shaped the landscape, resulting in diverse plant habitats that could support a wide variety of animals, from insects to mammals, creating rich ecosystems. Moreover, the activities of dinosaurs contributed to soil health and nutrient cycling. Their movements helped aerate the ground, while their droppings provided vital nutrients that propelled plant growth. As these plants thrived, they offered shelter and food to an array of species, promoting further biodiversity. The impact of these ancient giants stretched far and wide, creating habitats suitable for countless other organisms. When dinosaurs went extinct about 66 million years ago, the landscapes they had shaped did not simply revert to a previous state. Instead, the legacies of their existence paved the way for new evolutionary paths. This is evident in the diverse ecosystems we see today, as mammals and birds evolved to fill the niches left behind by these magnificent creatures. The presence of dinosaurs was a monumental chapter in the history of life on Earth, casting a long shadow that is felt in the rich biodiversity that continues to unfold. Dinosaurs, those magnificent creatures that roamed our planet for millions of years, serve as significant symbols in understanding the concepts of extinction and survival. Their history spans from the Triassic period, about 250 million years ago, to their sudden disappearance at the end of the Cretaceous period, around 66 million years ago. Their eventual extinction offers profound insights into how environmental changes can drastically alter life on Earth and highlights the delicate balance that sustains ecosystems. The mass extinction event that marked the end of the dinosaurs is often attributed to several factors, including a cataclysmic asteroid impact and extensive volcanic activity. This event serves as a critical case study for scientists studying extinction. It demonstrates how environmental shifts, either sudden or gradual, can lead to the loss of diversity among species. By analyzing the conditions leading up to this extinction, researchers also gain valuable insights into how current environmental issues, such as climate change, could lead to similar outcomes for today's species. Furthermore, the study of dinosaurs and their extinction allows scientists to explore resilience and adaptation in the face of catastrophic events. While dinosaurs themselves became extinct, their lineage did not vanish entirely. It evolved into the birds we see today. Understanding this transition illustrates how some species can adapt and survive drastic changes, while others cannot. This relationship between adaptation and extinction underscores the importance of flexibility in evolutionary processes, emphasizing that survival often favors those who can adjust to new realities. The lessons from the age of dinosaurs extend beyond history and paleontology. They resonate today as we confront our environmental challenges. The dinosaurs teach us that the fate of a species hinges not only on its physical attributes, but also on its ability to adapt to an ever-changing world. Reflecting on their story can inspire a sense of urgency to protect our planet's remaining biodiversity and to foster resilience in our ecosystems, allowing future generations to thrive amidst change, much like the birds descended from the mighty dinosaurs. When people learn about dinosaurs, a wave of emotions often washes over them, ranging from awe to curiosity and even fear. The sheer magnitude of these ancient creatures, some towering over the height of a house, ignites a sense of wonder. Dinosaurs inhabited our planet millions of years ago, which prompts reflection on the vastness of time and the unfolding story of life itself. This connection to something so immensely different from our world generates excitement and intrigue. Curiosity plays a significant role as well. People are drawn to the mysterious aspects of dinosaurs. How did they live? What did they eat? How did they become extinct? These questions create a thirst for knowledge that can lead to a lifelong interest in paleontology and history. The more we learn about their behaviors, habitats, and the environments they thrived in, the deeper our understanding becomes, which further fuels that initial spark of curiosity. For some, learning about dinosaurs can evoke a sense of fear, particularly when thinking about the formidable predators that roamed prehistoric landscapes. Dinosaurs like Tyrannosaurus rex or Velociraptor, with their sharp teeth and powerful builds, represent not just a different era, but the raw power of nature itself. This fear is often counterbalanced by a fascination that encourages people to explore not only the dinosaurs themselves, but the ecosystems that supported them. Ultimately, the emotions surrounding dinosaurs reveal our complex relationship with nature and evolution. These creatures, now long extinct, serve as a touchstone for understanding our own place in the natural world. They remind us of the planet's dynamic history, evoking feelings of both humility and a desire to preserve the life that currently thrives around us. Each new discovery in the field of paleontology lets us peek into this ancient past, continuously feeding our imagination and emotional connection to these magnificent beings. Dinosaurs have a unique ability to capture the imagination of both young and old alike. Their sheer size, diverse range, and the mysterious nature of their extinction make them fascinating subjects. For children, dinosaurs represent a world that is both alien and awe-inspiring, sparking curiosity about prehistoric life and the science that uncovers these ancient stories. As they learn about these creatures, they also begin to explore the rich fields of paleontology, biology, geology, and even environmental science. When young people engage with dinosaur stories, they often find themselves asking fundamental questions. What did dinosaurs eat? How did they live? What caused their extinction? These questions can lead to explorations of evolution, environmental changes, and the dynamic history of our planet. Each discovery about dinosaurs opens up avenues for further inquiry, helping to develop critical thinking and a fascination for scientific investigation. Moreover, the storytelling aspect of dinosaurs is powerful. Whether through documentaries, books, or animated features, these narratives are often tied to themes of adventure and exploration. This storytelling not only entertains but also emphasizes the importance of research and discovery, making science feel accessible and relevant. When children see paleontologists unearthing fossils, they visualize themselves in those roles, igniting a desire to learn more. In classrooms and at home, this enthusiasm can be nurtured through creative projects, museum visits, and interactive exhibits. By weaving together science and storytelling, we can foster an environment where young minds are encouraged to explore, experiment, and embark on their own journeys of discovery. In this way, dinosaurs not only inspire interest in science, but also help shape the next generation of scientists, thinkers, and innovators. The history of dinosaurs, which spans over 160 million years, offers a rich tapestry of moral and philosophical lessons that resonate deeply with our existence today. One fundamental lesson is the concept of adaptability. Dinosaurs thrived in a variety of environments and conditions. Their success in occupying different ecological niches reminds us of the importance of adapting to change and being resilient in the face of challenges. In our rapidly evolving world, learning to embrace change can lead us to new opportunities and a deeper understanding of our surroundings. Additionally, the extinction of dinosaurs serves as a stark reminder of the fragility of existence. Despite being dominant creatures, they were wiped out by catastrophic events. This prompts us to reflect on our own vulnerability and the transient nature of life. It encourages humility, reminding us that no matter how powerful or secure we may feel, we need to be aware of the forces of nature and the impacts of our own actions on the planet. This lesson is especially pertinent today as we face the consequences of climate change and environmental degradation. Moreover, the emergence of mammals after the dinosaurs' extinction showcases the idea of new beginnings. While the dinosaurs dominated for eons, their disappearance paved the way for mammals, including ourselves, to flourish. This emphasizes that endings can also be beginnings. In our lives, when we encounter setbacks or losses, we can draw inspiration from this lesson. Every ending opens the door to new possibilities, and it is often from adversity that innovation and growth emerge. Lastly, the history of dinosaurs highlights the importance of interconnectedness in ecosystems. Dinosaurs, like all creatures, were part of complex food webs and environmental systems. Their interactions shaped the world around them, reminding us that our actions can have far-reaching effects. As we navigate our modern lives, it is crucial to recognize how interconnected we are with the Earth and all its inhabitants. This awareness fosters a sense of responsibility towards protecting our environment, promoting biodiversity, and maintaining the balance of life on our planet. Each of these lessons from the history of dinosaurs invites us to reflect on our place in the universe and the shared journey of all living beings. Contemplating the life of dinosaurs invites us to reconsider our understanding of deep time and the intricate tapestry of evolution. Dinosaurs roamed the Earth for approximately 160 million years, a span that far surpasses the mere existence of humanity, which has only been around for a few 100,000 years. This vast timescale can be mind-boggling. In the grand scheme of geological time, human civilization is but a fleeting moment, reminding us that life on our planet has been shaped by processes that take place over unimaginable lengths of time. Dinosaurs themselves were not a single static group of creatures. They were a diverse array of species that evolved, adapted, and thrived in changing environments. Some evolved into the massive, long-necked sauropods, while others developed the speed and agility of small theropods. This evolutionary experimentation leads us to appreciate that life is not a linear progression, but rather a rich, branching tree of possibilities where each organism is a response to the pressures of its surroundings. As we explore these evolutionary paths, we see a vivid picture of adaptation and survival that continues even today. The extinction event that wiped out the non-avian dinosaurs serves as a stark reminder of life's fragility and resilience. About 66 million years ago, a cataclysmic event, likely triggered by a massive asteroid impact, dramatically altered Earth's climate and ecosystems. It reminds us that change is often sudden and unpredictable, reshaping the course of life in a heartbeat. The consequences for the dinosaurs were dire, yet this event also paved the way for the rise of mammals and eventually humans, demonstrating how extinction can lead to new beginnings. Reflecting on the dinosaurs urges us to embrace the notion that both time and evolution are far more complex than they may seem. Each era of life builds upon the last, like an intricate tapestry woven over eons. Our place in this vast story of life challenges us to think about how we too are interwoven into the fabric of Earth's history, and how the legacies of those magnificent creatures still resonate within our planet today. Studying dinosaurs is like stepping into a time machine, where every discovery paints a clearer picture of our planet's distant past. For many paleontologists, the moment that transforms their understanding often comes during fieldwork. Imagine unearthing a bone that has laid buried for millions of years. That rush of finding tangible evidence of creatures that once roamed the Earth is incomparable, bringing the ancient world into sharp focus. One of the most enlightening aspects of studying dinosaurs is grasping their evolutionary journey. These remarkable creatures thrived for over 160 million years, adapting to various environments and climates. Understanding how dinosaurs evolved into birds is particularly fascinating. This connection highlights the intricate relationship between extinction and survival, showing us how once mighty beings adapted to changing conditions and ultimately gave rise to modern avian life. Additionally, the sheer diversity of dinosaurs is mind-boggling. From the massive Argentinosaurus, which could weigh as much as 15 elephants, to the agile velociraptor, studying their anatomy and behaviors reshapes our view of life on Earth. Each new fossil discovered adds another piece to the puzzle, revealing the dynamic ecosystems in which these creatures thrived. It's a reminder of the complexities of evolution and the stories written in the layers of rock. Lastly, the realization that our current understanding of dinosaurs is always evolving is transformative in itself. As technology advances, so too does our ability to analyze fossils and uncover new insights, whether it's through advanced imaging techniques or the study of ancient proteins. This continual revelation keeps dinosaur research alive and vibrant, making every day in the field an opportunity to rewrite what we thought we knew about these incredible creatures.